Hello, welcome back. Please welcome to the stage to the chair of this the afternoon session, Luce Martí.
Thank you. So this afternoon we have the session on AI applications, and the keynote of the session will be presented by Luce. Luce is Luce Brotcorne. She's a senior research director in Inria, in the Inria Center in the University of Lille, and also the head of the Inox project team of Inria. She has a PhD from the Université Libre de Brussels, and her area of expertise is bilevel optimization with applications in different areas like management and pricing and all of that. She's also a very good friend of Chile, and we have been having different forms of collaboration with her. Today she's going to be presenting a keynote on this topic on bilevel optimizations, applications in energy and transportation. So please, Luce, thank you very much, and the floor is yours.
So thank you, Ruiz, for the introduction, and thank you for the invitation to be part of this event. So in Inria Chile, devoted to artificial intelligence. So just, I will first start my talk with a reminder of a definition of artificial intelligence given yesterday by Parte. Okay, so a lot of people are talking about artificial intelligence, but really it's a broad topic and it involves a lot of things. So just I would like to remind you that we will consider moderate AI. So in fact, we will here talk about decision-making tools. So we will, in this talk, I will show you how we can define some tools, and the goals of these tools is to help the people to take decisions. So in some sense, we are defining some tools. All the goal is to reproduce and imitate human behavior. So I hope I will convince you during this talk that this type of tools could be quite useful. So just the outline of my presentation, I will give you a brief introduction of bilevel programming, and then I will explain you why there are new challenges in the energy field. And then I will consider different applications of bilevel optimization, two in energy and one to prevent fare evasion. So the two last applications are joint work with professors and students here in Chile. So just introduction. So it's dessert time. And so let's consider this chocolate cake. And just I take an example. So let's assume that, so first I will tell you that I am very fond of chocolate. And so I will need to cut this cake. And for example, let's assume that I will share the cake with Ruiz. And so I don't know if he likes chocolate cake or not, but if I know that he is really fond of chocolate cake, I will try to cut the cake into two equal parts, because I know that he would like to take the largest one. But if I think that it's a lazy guy and I will just take the piece in front of him, I will try to cut it in a larger piece, with larger pieces for me. So just with this small example, we can see that here, in fact, when I cut the cake into two parts, I try to integrate the behavior of Ruiz within my decision-making process before taking my decision. And in fact, bi-level problems are just this type of settings, this type of model, who try to represent this type of hierarchical decision-making process. So easy. Not so easy, we'll see, but just I try to give you some intuition in the problem. So just as I am more formally, so we will consider here decision-making process involving different stakeholders. And we will consider that the stakeholders are deciding this sequentially and in a hierarchical way. So I will consider that we have a leader. So before the leader was me, because I had the task to cut the cake into 2 pieces, and a follower. And when the leader takes his decision, he integrates the behavior of the follower within the decision-making process. So it's related to, it's quite multidisciplinary, because it's related to the principal agent paradigm on economy, to equilibrium problems, to game theory. And if we consider the origin of bi-level optimization, in fact, we go back to the Stackelberg paper defined in economy, just representing this type of interaction and finding for an equilibrium between the decision makers. And after that, there were more other papers trying to model this economical problem with mathematical equations. So now let me consider formally a model. So I will give you some equations, not too much, but just some of them, but in order that you have the intuition into the problem. So, okay, so you maybe if you are familiar with optimization, okay, so you know that here in constraints optimization, we want to optimize an objective function on a domain. Okay, so I think that a lot of people here are familiar within this type of formulation for optimization, whatever the properties of the objective function of the constraints. And what is a bi-level optimization problem? So as I mentioned to you, we have 2 types of decision makers. We have a leader and a follower. So let's assume that the leader is, the variables of the leader are x1 and the variables of the follower are x2. So just the leader optimizes objective functions depending on his decisions, but also on the decisions of the follower. And the follower, he also optimizes his own objective function. Okay, so here we see that within the decision-making process of the leader, we integrate the decision-making process of the follower. And so it can be seen as a mathematical program, okay, involving another one within its constraints. And in fact, the study of this type of problem has been known formally and theoretically up to the 18th. And just when people realize that it's really suitable to model pricing problem, more and more people were working in the field. Why? Because, of course, in a pricing problem, for example, you want to determine some prices or some goods or services, okay? And you want to maximize revenue. So it's an old problem in economy. And generally, to obtain the demand, people consider some demand prediction function, statistical demand prediction function of whatever. But in the 80s, a lot of things have changed with the development of internet. Because, for example, before, if you wanted to buy a flight ticket, you were going to an agency, and in fact, you bought your ticket, but you had not a lot of choices, maybe 1 or 2, but no more. But after that, with the development of internet, the customers were really more strategic, okay, because they were able to compare the offers of different companies, the offers depending on the time of the day you were living, and so on. So they had a strategic behavior. And so the previous approaches to determine the prices were not suitable anymore, because they were not able to take into account the strategic behavior of the customer within the optimization process. And that's why bi-level optimization programs were really useful, because as I mentioned to you, intrinsically, okay, due to the formulation, they integrate the behavior of the customer comparing different offers. Okay, so of course, as we will see later on, it's not easy to represent this, the choice of the customers. And in fact, there are a lot of things to do there, and for example, integrating some learning approach. But let's go further, and I will show you some examples. Just why it was a success. Just I take you a small example on a network to show you that by considering bi-level optimization program, you have a global solution. You take into account globally all the interactions. For example, let's assume that here you want to define some tolls on highways. Okay, so maybe it's not common here, but in Europe, you have, in France, you have a lot of tolls on highway. And so let's assume that here you have only one person, people going from this node, from 1 to 2 and one from 3 to 5. And they have two alternative paths. So this path with cost 8 and the other path with cost 5. And they could also choose to go with this path or with this path. But there we need to define the tariffs, the tolls, to put on the arcs. And the company in charge of the highways, of course, wants to maximize the revenue. So want that people use the toll path. And just if you check, okay, and you want to define the optimal tolls you can put on the arc, you see that here the maximum tolls is 5, and here the maximum tolls is 2 in order to attract the people. And so what's the optimal solution? Okay, so just a few minutes. In fact, if you want to attract all the people on the path, okay, what you do is that you put here a toll of 5 and compensating this 5 by a -3 here. It does not mean that you will give -3 euros or dollars to people, but it means that if they pay globally for origin destination, you globally you take a global decision in order to attract a lot of people. And this example really was disturbing a lot of people, but in fact it's what's happening, because sometimes if you check the train ticket or flight tickets, it does not depend on the distance, okay? Sometimes if you use longer trip, you pay less than if you use shorter one, because they want to attract people on some path. So, as I mentioned to you, so there was a lot of success in the study of bi-level optimization due to the pricing approach in different fields. And in fact, we had a success story with some colleagues in Montreal. Based on this paradigm, we created a company, Expressio, based in Montreal. And the goal of this company is to determine the price of a train ticket. Okay, so if you go to Europe and you visit and want to buy some high-speed train ticket, you will suffer a pricing and revenue management approach like in the airline industry. But so they also have application now with leisure, with car renting, and so on. So a lot of potential there. Just a few words. I say, okay, it seems to be easy when I explain I took the example with the chocolate cake. It was supposed to be easy to model, but in fact, when you, maybe the bi-level optimization problem are quite natural to model pricing problem, as I mentioned to you. But if you want to solve them, it's not that easy, okay? So just a few words for people who are familiar with optimization problem. In fact, they are non-convex, non-differentiable, okay, so not nice. And okay, just also because it's similar to multi-objective problem. But the bad thing is that because you have the objective of the leader and the objective of the follower. But the bad thing is that it's not a multi-objective problem, because we can prove that the optimal solutions of bi-level optimization problem are not Pareto optimal. Again, to give you some insight into why it's difficult, okay? Just, I do not want to bother you with a lot of questions, I just want to give you some insight into the problem. Let's assume that simply, okay, all the functions are linear, okay, just. And we consider that, so here you have your feasible set, okay? The direction of optimization of the follower, direction of optimization of the leader. Okay, and up to now, I consider that I have no constraints for the leader, only constraint for the follower. So you see that if you optimize only the objective of the leader on the feasible region and you totally forget the objective of the follower, the solution is this point. Now, if you consider really the bi-level optimization problem, so it means that each time the leader chooses one point, okay? You have an infinite set of reactions for the follower, but he will select the one going in this direction. Look, he will select this point. So just here, okay? So here I take a decision of the leader, or the feasible solution of the follower, but as he optimizes his objective in this direction, it's this solution. And so, in fact, if you consider the bi-level optimization problem, you only optimize your objective on the union of these three segments. So just with this simple example with linear functions, okay, and you see that it's not really well behaved from a mathematical point of view. And if you have constraints for the third level, in fact, you may have also disconnected feasible region. So just so that's why, in fact, there are several types of solution approaches to solve this type of problems. But if you want really to solve a large-scale problem, you need really to rely on the structure of the problem. So just before considering the examples, just I would like to comment on several points. So just we can have some particular cases. For example, so I mentioned that the leader optimizes objectives, taking into account the reaction of the followers. But I never said that the reaction of the follower is unique. Okay. He may have the choice among different alternatives, optimal for him or her with respect to the decision of the leader. And what do we do with that? In fact, so for example here, so we have the x variables for the leader and y for the follower, okay, and we see that if x equals 1, we are in trouble because we have an infinite number of reactions possible for the follower, or the value in this segment. So, in order that the problem may be well defined, in fact, we can assume that the optimistic case that the follower, when he has a choice among different optimal solutions, he will choose the one favoring the leader, or he will choose the one which is not really favoring the leader. But more generally, in the literature, we consider the optimistic case because it's much more, if you consider application, it makes sense because, okay, with frequency program and so on, so we can induce some behavior of the follower. In terms of complexity, again, it's not easy with bi-level optimization problem belongs to the class of sigma 2p problems, which is not really a good complexity class. And some other considerations, I just present you, I say a leader and a follower, okay. But in the application for pricing, there may be a leader, a company, but several followers, a lot of people buying the tickets, okay. So it's a case, and in fact, it's a case when you have a single leader, multiple followers, and we can consider different type of interaction. Either they are independent, so they buy their ticket independently on the decision of the other. Or, okay, they may be linked together. For example, if you consider to determine some tolls on the highways, okay, so the choice of the path of somebody in a network influences the travel time of everybody. Okay, because if everybody uses the same path, you increase the travel time on this path. And if you change your mind, it will affect the travel time of other people. So it means that it was not the case in the small example I consider, because I was not considering dependency on the cost with respect to the number of people on the path, but generally we have dependency. And so in that case, we in the case with multiple followers dependent. So it's related to game theory. And so it's just about the solution approach, but just can consider, so as I mentioned, a lot of applications of bi-level optimization. We have application in pricing, electricity market, we will consider that later on. Last year, my colleague presented application in logistics. We have also interdiction program and critical infrastructure defense. And also, from a theoretical point of view, there are a lot of links between bi-level optimization program and robust optimization. So when you take decision in the worst case, the nature could be here represented by the follower, or two-stage stochastic optimization. And more recently, there were links with machine learning. So just if you consider GAN problems, if you are familiar with GAN problems, generally people are talking about zero-sum game, but it's not really a zero-sum game. And in some paper, they mention Stackelberg game and so on. And so we started a work on that, and we published a paper on that with people in Montreal on the Mila. Just by considering this link, in fact, we could solve other type of instances. So it's about relationship, but also, as I mentioned to you, when you consider bi-level optimization problem, you need to represent the behavior of people in the second level. And just to represent the behavior of people, generally you rely on rationality assumption, but even if you consider rationality assumptions, you need to model the behavior, the interaction, the reaction of people. And to model this reaction of people, you can calibrate some parameters on data, or you can use some learning approach, or there are a lot of studies now who try to integrate learning model in the second level problem in order to better capture the reaction of people. So there are a lot of research to be done in that field. It's really an open field and just a new field also, and there are a lot of things to do there. So just for you, so if you are interested in the topic, so just we are creating a new society, because in fact there were several conferences devoted to bi-level optimization before. So one in France, one in Lille, and the last one was organized in Chile last January. So it's really a new society with a lot of research to be done and also practical applications, okay, and a lot of students. So if you are interested in that, you can connect on the website and register. It's free, of course. And but you will be aware of all the events and also all the new trends in connecting bi-level optimization with AI and with learning. So let me consider now the application. So just why a lot of people now are working in the energy field. Okay. They are working in the energy field because the things have changed in the last decades. So before, maybe 20 years ago, if you were working with energy providers company, their goal was to produce at the minimal cost. Okay, so they had a demand, they had different technologies to produce electricity, and just they were running the unit commitment program, okay, so they just wanted to produce enough electricity to be able, at the minimum cost, to be able to satisfy the demand, depending, using different type of technology, depending on the cost of the technology. But nowadays, the things have changed. They've changed on the two parts. First, on the demand part, okay, so even if the houses are, well, more, the installation of the houses is of better quality, and we see that the demand tends to increase, not regularly over the day, but we tend to have larger peaks. And again, if you consider the development of electrical cars, it could be worse in the next year. So just on the demand, we can observe a lot of variation. But the most important thing is on the offer, because on the offer, in most countries now, are just putting into highlight the production of renewable energy, okay, solar or wind. And which means that now the offer is intermittent. Okay, so you are not able to produce a lot of quantity of electricity at any time if you rely on renewable energy, because it's difficult to store energy. And so these 2 points make that just we completely change the paradigm. So before, we needed to adjust the offer to the demand, but now it's not the case anymore. It's the contrary. Now you need to adapt the demand to the production, which is intermittent. And to do that, okay, so it means that you will rely on flexibility, different type of flexibility. You want to change the habits of the people in order that they consume when they have electricity and reduce their consumption in off-peak periods, okay? So you have a lot of new challenges with respect to the production, but also with respect to the network. So I won't talk about that here, but of course, with respect to the network, you have a lot of new challenges. Also, what appears is that you have new local community of energy, so people who can produce their own electricity and consume, and they are interconnected in a neighborhood, and they are connected to the grid, okay? So how are we managing with that, okay, their connection to the grid? So really a lot of new problems that feel involving, as I mentioned to you, different stakeholders with different type of interaction. So so it's just a summary, I think, of IT. And also in France, what we had in the recent years is the deregulation of the energy market, okay, which also made a lot of difference with respect to the market's definitions. So now we have the new picture. So this was provided by my colleagues in EDF, and we are collaborating with them at that point on some particular problems. So it means that, as here we can see that you need to take into account different type of customer, and some of them may be flexible or not, and by using some, for example, some incentive approach like pricing, so you would like to change their behavior, and I will just show you an example in a few slides. But you have also new challenges appearing in the electricity markets, because now it's deregulated, and you have also different type of producers with different type of technology and with new challenges. So really a new bunch of problems are there in that field. And I will consider two of them, so just quickly. So just one basic one, just about demand-side management. So demand-side management is a set of tools whose goal is just to be able to change the habit of consumption of people. So just to give them incentives to change their habit and just to consume in off-peak periods. So we will just hear the time of use pricing. So we'll be able to define some different prices according to different time, in order that people some people are quite sensitive to price, and so they will change the habit. And of course, it makes sense if it's automated, because it doesn't make sense that you are checking the price of electricity at any time, and okay, it's cheap, I can consume, it's quite expensive, I try to reduce my consumptions, okay, so you have a lot of things to do in a day and not taking care of that. But if you consider some intelligent smart meter in France Linky, you can rely on automatic tools in order to be able to adjust the demand of people according to the variation of price. And so it's just to show you that it's happened. So it just no, you can have this type of prices also in France, but it started earlier in the UK, and so that's what it points. It's a picture provided by my colleague from Edinburgh during the COVID period. Okay, just to show you that it's not a dream. Okay, it appears now, and you can have time varying pricing according to the day, and also you could have some negative tariffs when you produce a lot of electricity. And for example, when renewable energy, sometimes you really produce a lot of electricity, and so you need to consume, because otherwise, if you inject too many electricity within the network, it can be dangerous and you can black out and so on. So just to, you would like to prevent that type of thing. And it appears also in France nowadays, and we had a discussion quite frequent in the last days with colleagues from EDF. No, so it's not possible anymore to have negative tariff, but they try to use some tools just to prevent blackout due to the fact that at some time you produce too much electricity. So just a case, just to give a flavor of what could be done, okay? It's a simplified, but we consider self-extension. We consider simply the case when you have a supplier of electricity, a seller or producer, whatever, and the goal is to determine some prices in order to change the habit of the people, to maximize revenue and to minimize the peak. And the follower is a smart grid aggregator. For example, if you are in your local community, okay, and you are connected to a smart grid aggregator, and this smart grid aggregator takes care of all the people of the community. So it asks to people, okay, what they would like to do during the day. So what is the preferred time just to do to wash dishes, whatever, what they do. So just the appliances they want to use in different times window. And also the characteristics of these appliances, and the goal of the smart grid operator will be just to schedule the appliances of the customers in order to maximize the sum of cost. So just this can be modeled as a bi-level optimization problem, okay, as I mentioned to you. And so just here we consider, in this case, for the results, I will show you non-preemptive devices. So no, preemptive devices, so like heater or cooler, because you may be able to vary the temperature over time and so on. So it just, it's easier to solve because you will have continuous variable. But we consider also the case in our study. I will show you some references if you are interested in that topic, where you can have preemptive and non-preemptive devices. So just like a washing machine, when you start a washing machine, you cannot stop in the middle and start again. Okay, so just in optimization, it means that you will have integer variables and making the problem much more complicated to solve. So just, I think I won't consider the model here. I don't know how much time do I still have? Okay, so I won't skip that. So just if you are interested in that, you can contact me. I can give you some references about what we do, and also we consider just the competition among different companies providing electricity. Okay, so just it was a simple case, but we did a lot, and there are still a lot of things to do. And just now we started a new PhD thesis with EDF, and just the goal of this new PhD thesis is to define new contracts with customers, involving some flexibility again. So just again, the goal is to incentivize, to change the habit of the customers. And just with respect to what question asked in the morning with respect to energy, also for cloud providers, okay, you could, and we are using that type of modeling approach for frugal cloud, okay, because we are working with a French company, OVH, and they just realized that a lot of people rent computers for a long time without using them, and it's a cost because the computers are on, and so it consumes electricity. And sometimes other customers are arriving with some special demand according to time. So with this company, we develop a new tool just in order to incentivize people renting computers for 1 month in order to just say, okay, I am not using it during from 2 to 5 on Monday, for example. So they relax them, and so other people can use this power. And so by doing that, they will reduce the consumption of the appliance. And we are working on that with another team in Inria, in Lille, Spirals, who is really specialized in measuring the consumption of the jobs on the computer. So just it's really related to the characteristics of the job. So, but just let me go back to, so just it was the result we could have with the previous case. So you see that when you increase the prices, I don't know, it's not working. Okay, when you increase the price here, okay, the impact is just a reduction of the demand, and the more impact you give to the reduction of the peak, the more you reduce the peak and the more you increase the price. Just let me consider now, to finish my talk, 2 cases that we are studying with, so it's a collaboration with researcher in Chile. So if in the future there will be a joint Inria France and Chile team, I think we could be a good candidate, because we consider a collaboration a long time ago with some professor here in some university. So I will first consider a collaboration with my colleague from Lille, Hélène Lecadre, and from Alejandro Joffre. So in fact, this collaboration started before COVID, and with a really clever master student, Daniel, but he started his PhD, and due to COVID and personal reasons, he needed to stop his PhD. But it's a topic that we investigate again in the last months with a new master student, who I think is in this room. So just let me give you a flavor of what you are going. So we are in the electricity market. Okay, we would like to model an electricity market. So what happens in an electricity market is that you have different producers, okay, and the producers are different technology. So here are the producers, okay, and they have different technology. So on the day-ahead market, okay, they beat a cost function. So it means associated with the quantities they are able to produce, and the ISO, okay, which is an regulation instance, will knowing, so just maybe consider that, so knowing all the bits of all the firms and estimation of the demand, okay, we run an optimization program to minimize the sum of the cost, and we define the quantity that each producer will need to produce at the given price. So it's a classical day-ahead market in the energy. But what we do in our project is that we consider that, and what is new, okay, in the new, in nowadays, that the producer may have different technologies, okay? So they have renewable energy and other type of production. And so when they define their bits, they can bid on with cost function associated with the different type of technologies. And so that's new, quite new, and but again, the new markets need to be able to deal with that type of new bits. And so if we consider in terms of bi-level optimization problem, so of course, each producer needs to define his bits, taking into account that the ISO will receive the bit of everybody and define the quantity and the prices for this transaction. Okay, you know that. So he solves a Stackelberg game. But you see that you have different producers. Okay, so they are competing together. So again, when somebody takes his decision, it takes into account the ISO decision, but also it takes into account what the competitors will bid. Okay, so here we have several leaders and a single follower problem in the case of bi-level optimization problem. And so it's this type of problem we model. So I won't give you all the maths behind this approach, but we are able to model that as a multi-leader single follower problem. We are able to study the property of the model, and we are computing some solution. And what we introduce now with the master student is that, okay, we take into account the fact that if the producers have several technologies, and as we would like to favor renewable energy, in fact, the ISO will change its habits, and it won't only take into account the global minimization of the cost, but also it will take into account some pollution impacts. Okay, so just to favor the renewable energy. And in that case, of course, you have uncertainty about the production of renewable energy, and you have, as I mentioned to you, so here one agent needs to take into account the strategy of the other, and then to represent the strategy of the other, you have different possible approaches. You can assume some scenarios. You can also consider some learning approaches, and so there are some literature there introducing some learning within a multi-leader single follower game. But again, if you are interested in that topic, there are still a lot of things to do, and because in order to be able to integrate it, learning models with good properties within this approach. And the last applications I would like to consider is just for security, and it's stackable games, and also it's related to bi-level optimization when you, a leader, would like to secure some places. He has a limited number, for example, police officers, so they have a limited number of police patrols, and they want to secure a place. Okay, and so the goal is where to locate the patrols in order to secure the place. So you have a lot of application about that. So just to prevent, to prevent contraband, you have also in some parks, if you want to protect some animals from, I don't know how to say in English. So people who want to kill animals in parks due to okay, and you have also different applications, and one guy working a lot in that field is Milin Tambe in Los Angeles, and he designed several tools in order to protect the airport of Los Angeles and so on. But we will consider here application, and so this collaboration, in fact the collaboration with Chile started on this topic maybe 6 years ago with Fernando Ordonez, Vladimir Marianov, and after that it continued with Pablo Escolana and Victor Bucare and my colleagues in team. So we started the collaboration in that field a long time ago. So here are some joint paper, but I will focus now on an application in fare evasions, okay? And because what is fare evasion? So just people using public transportations, okay, when you use public transportation, buses, for example, you have always a choice, okay, I buy a ticket or I don't buy a ticket, okay, just you have a risk measure. Do I try or do I am risk averse or not? Okay, so just, and in fact, you can see there that you have figures in Santiago and in different countries that you have the percentage of fare evasion is quite important. Okay, so the companies, of course, do not like that because they are losing some revenue. And also it's for respect to the people who pay every day, it's not really fair. So we consider a case where we have a proof of payment. So it means that you buy a ticket before using transportation, but you do not go through a barrier. Okay, like in the metro, you go through a barrier, but here no, okay, you buy a ticket and you take a bus, but there is no control when you enter the bus. So we are examples here in the region of Santiago, and of course, as I mentioned to you, you have what we say opportunistic passengers. It's passengers who decide not to pay, and they are increasing. So we have developed with our colleague non-predictable and cost-effective spot strategy. So we define where the people, okay, who will control the buses on the tram in order to reduce the number of people who do not pay. Okay. Of course, people who decided not to pay learn from what people are doing, the companies are doing. Okay. So if they are always at the same place, if they use a pass going through that station, of course they will pay. So it has to be unpredictable, okay? So the location of the spots where people make some control need to be unpredictable. We model that as the Stackelberg game when the goal of the leader is just to define where is the transit authority. So where and how often they will inspect one location, and the followers are the passengers which observe what's happening and adopt also a strategy with respect to that. And of course, in our model, we consider that we have opportunistic but also honest passengers, and the people will choose a path with the lowest probability of inspection. So we assume that they have different potential paths, okay, which have travel time which are almost similar. So we test that, okay, so I think it's, and with different strategies, because we are working in different countries, with different continents, with different habits. And so my colleague Pablo in Chile told me, so okay, for us, people will go, enter into a bus, control the people, the bus stop, and go out. I say, no, in Europe, don't think about that, because you will have a lot of delay and people will be unhappy. So people are going into a bus, they control, they go out, and they continue, and maybe they can take another bus. So it's two different strategies according to different countries. So we tested the two approaches with our model. And so we tested our approach. So unfortunately, we had not data for either for the network in Lille, and we could have data about the network, but the problem is to have data about, again, the estimation of the probability, okay, when people make a choice of path, okay, so the probability of to be controlled or not. And to do that, so we need to have data to work with companies. So we had contact with the bus provider company in Lille, but finally it was not successful. So just again there, we rely on data of people working in statistics. So we were working in a team in Lille about model with statistics able to estimate the probability of taking this path, knowing that you can be controlled or not, or you can use some learning approach to define this data. So as we did not had the data for a city in Chile or in city in Lille, we use the Berlin bus network, which has this shape. And for example, here we have the result we could have where we need to locate people. But just let me show you some, in fact, it's just the figures here may not be really important, it's just a tendency, and just the goal here is to prove you that with using this type of approach, we can define some efficient strategies to reduce the fare evasion. So just you consider edge, so when you, edge is when you enter into a bus and you go in, or districts and when you enter, it's a Chilean way. Let's say like that, so we would be able to reduce the number of fare evasion, not with a lot of inspection team. So I think it's quite important. So just if you have a limited resources, but if you plan properly where to locate the people and define good strategies to take into account the strategic behavior of opportunistic passenger, you're able to really to reduce fare evasion by a large number. And again, if you consider that in a day-ahead operation, so because of course the people are learning what's happening from day to day, and so if you repeat the process over day, you can see that after 5 days you can really decrease the number of fare evasions. Just the conclusion. Okay, so just it's the conclusion for this part, but just to mention that in fact, when my colleagues presented this paper, people from the Ministry of Transportation were quite interested in that field, and it led to the submission of a proposal to this proposal of a project, and we hope it will be successful because it will help up in the future to strengthen our collaboration with Chilean professors. And concerning the conclusion of my talk, so I hope I have convinced you with the bi-level optimization program. So it's a tool in AHE able to define some decision-making process to help people to take decisions in different contexts, okay? You have a lot of applications in different, in energy, transportation, and so on. There are still a lot of things to do. So for your research, if you want to work in that field, if you are more from the territorial point of view or more applied point of view or more working on data and learning, you are still a lot of things to do in that field. And and also there are connection, as I mentioned to you, with other field of optimization. And again, if you are interested, do not hesitate to register for the new society.
Thanks. Thank you very much. Do we have any questions? Any question online? Either? Oh, Yinoussa is here. Let me.
Thank you very much for this presentation. I just have another a small question. Like, do you have another software for people to take bus to not pay? Or? So yeah, my question is about my question is about the data you are collecting, like for Lille. Which kind of data do you need? Like, like only the bus station, only the bus, or you also need like the number of people in the bus and all these things. And also when you talk about the city, I imagine that you have the cultural things inside this. How do you take into account? Like, I know that the behavior at Lille is not the same as Paris. So how do you take into account these kind of things in your algorithms?
Yeah, indeed, it's a good question. So just you need to have data, global number of passengers per day, per time period, and so on. So it's data which are not too difficult to obtain. But after that, you need to have the number of people, because the cities are doing some control. So just, sorry, but with the light, it's difficult to see you when you are here. So just, and we need to know, because when people make control, generally how many people do not pay, okay? So we need to have that type of data to be able to estimate after that the probability of the users to select a path, knowing that there is a control patrol there, or assuming that there is no control patrol there. Yeah, in fact, you need a lot of data about the habits of the consumers, about the fact that they are more risk averse or not, and it really depends on the companies providing the public transportation. But in fact, we can. The methodology is almost the same, but we really rely on data depending on the place we are testing our approaches.
Oh, okay. So we have a question online from Rodrigo Vargas. What opportunities do you see for the application of bilevel optimization in the management of the Chilean electrical system, particularly in the context of deregulation and the growing participation of renewable energies? The question is, what opportunities do you see for bilevel optimization in these two areas? So, well, in the management of the electrical system in Chile, taking into account two things, deregulation and the growing of renewable energies.
Yeah, in fact, there are a lot of opportunities, of course, for Chile, because we are producing a lot of renewable energy. And so the general problems I mentioned here could be applied, but with some specification to the case of Chile, relying on the size of the country also, because we have distributed networks, because the production is distributed before it was centralized. So of course we need to take into account the heterogeneity of the productions. And the disparity of the size of the producers, and also the fact that people are more or not reluctant to change their habits. But it's a question of data, but the global paradigm could be applied, of course, but just we need to take into account the particularities of the country when we define the solution, we test our approaches. And I don't know, and about with those electrical cars, it was that?
No,
okay.
Renewable energies, but I think you already, the deregulation of renewable energies. Thank you. Well, I have a couple of questions, but we are running out of time, so I will turn my questions into a comment. You mentioned the possible point of contacts with machine learning, and besides GANs that already have this dual, part of the failure, let's say, or not success of GANs is because exactly finding this balance between conflicting modules learning is very hard to achieve. we have been working, and tomorrow actually we have a session on those topics, but on this relatively new approach called physics-informed machine learning, that is again the same of trying to learn from data and from existing models. And listening to you, I think it would be interesting an interesting approach to follow. No? So let's talk about that later. We ran out of time, but thank you very much.
Yeah, thank you. Just a comment that you are totally right. Okay, and just no new trends also in the community. Just to integrate bilevel optimization within training approach. Okay, there are people working in that field. And as I mentioned to you, there are people also working on the field just to replace the lower level burden by a learning problem, because it can be also modeled. Okay, here we assume that the follower is the rational reaction of an agent, but it could be the selection of a solution in a set with a given probability, and this set could be given by learning approaches. So you are also new trends that, and of course, there are a lot of collaboration possible.
Very interesting. Thanks. Thank you very much. Any other question? No? Well, thanks. Thank you very much. Well, and the next presenter is Javier Ruiz del Solar. Javier has a PhD from the Technical University of Berlin and is the founder and executive director of the Advanced Mining Technology Center, AMTC, and full professor at the University of Chile, in Chile. So Javier works in the field of learning and perception in mobile robotics, and his presentation will be around deep reinforcement learning for mobile robotics in mining. So thanks, and thank you, by the way, for accepting to present. The floor is yours. Thanks.
Hello, everybody. Thank you very much for the invitation. So now we will change the subject. We will talk about reinforced learning, deep reinforced learning, and the application of these methodologies in mobile robotics and in mining. So we will talk about robotics and we will see some videos. Okay. First, a very short motivation about the need of using reinforced learning in mobile robotics and in mining applications. Then I will give a short explanation of how reinforced learning systems work and which are the main difference between reinforced learning and deep reinforced learning. Next, we will talk about some of the main challenges of reinforced learning. And after that, I will present some of our applications of reinforced learning in robotics and in mining. Okay, let me see the time. We will start with the motivation, So we use reinforced learning in robotics because we need to have some learning in robotics for solving complex problems. So in this video, in your left-hand side, you see our soccer robotics team about 15 years ago. You used to participate in these competitions. We were one of the top teams. And we realized that we needed a way of improving our behaviors, and this required learning. And we discovered that the proper paradigm is reinforced learning. In the second video, it's about 5 years ago, is the automation of a mining machine. This is called an LHD loader. This is our implementation of this automation. This video is from this machine working in a mine in the north of Chile. And again, the way of addressing one of the challenges is through the use of reinforced learning. So why I am talking about reinforced learning and not about learning in general? So let us suppose, as in this diagram is shown, that we need to control a given machine. In this case, it's a bicycle. We want to have an autonomous bicycle. So we think, or we assume we can solve this problem using a controller which is based on machine learning. So for controlling this bicycle, so we need to get data from some key sensors. In this case, from a sensor that can measure the steering angle and the inclination of the bicycle. So with these input variables, our machine learning algorithm will produce some control signals to the actuators. And in this case, these control signals are orders for the steering motor and for the traction motor. So from the conceptual point of view, this is very easy. But the problem is that you don't have the data to train this learning machine. Why you don't have the data? Because what you need is at any time, at any moment, for a given combination of the input variables to know which is the right output variable. So you don't have that. There are some special cases in which you have this information, and these cases is when you are copy a solution that already exists. So you are copy an expert. This expert could be a human being, or the expert could be another system that is not based on machine learning. It could be a control algorithm. So, but if you don't have that, you cannot apply supervised learning. But you can apply reinforced learning because, as I will explain, under the reinforced learning paradigms, so you don't need to have the right answers that the machine needs to give. But what you need to have is an assessment of the actions that this controller or this agent will produce. So we need signals that tell you how good is performing this controller. And these signals, according to the reinforced learning paradigms, are called the rewards. Yeah, the reward signal or the reward function. So when we apply reinforced learning, we are addressing problems that you cannot address using other learning paradigms as supervised learning or unsupervised learning. So what is reinforced learning which is a very basic idea. So you have an agent, and this agent is able to act in the world. How the agent act? Through actions. So the agent can perceive the world. It has a model of the world, and according to the state of the world, or according to the model, it chooses actions. But the actions, he can also assess how good the actions are, and how this assessment is done using this reward. Of course, there are actions that have no rewards, there are actions that have positive rewards, and there are actions that have negative reward. So using this reward information, the agent can learn and can choose the right actions according to the model that the agent has of the world. So in one very short sentence, what is reinforced learning is learning by trial and error. If we use a longer sentence, the basic idea is that based on the Markov decision process framework, the reinforced learning addresses the problem of how an autonomous active agent, so an agent that can take decisions, learns the optimal policies while interacting with an initially unknown environment. So this is what we want to use for training our robots or our autonomous machines. Is reinforced learning a useful tool? Here are some examples which are based on applying reinforced learning for solving the problem, or parts of the system are based on reinforced learning. So it has been a very useful learning paradigm. So let us explain in more detail how it works. I already said that this paradigm is, or applying reinforced learning is based on these Markov decision processes. So this Markov decision processes is a formalism for sequential decision problems. So every time that you have a sequential decision problem, you can formalize this as an MDP, and if you have data, you can apply reinforced learning. So an MDP is defined by a set of states, a set of actions, a transition function that tells you how you move from one state to the other state when you execute an action, a reward, which are these signals that allow, as I already said, that allows to assess how good are your actions. And you have, or you can use, it's not mandatory, but you can use a discount factor. This discount factor tells that the actions have different value. Sorry, the rewards have different values depending on when you obtain it. It's like money. It's not the same value of the money in time, okay? So basically, the agent is in a given state, execute an action, transit to a different state, and obtains a reward. The reward could be, as I said, null, positive, or negative. So, which is the goal of reinforced learning? So the goal is that how it works, the agent will interact with the world. This interaction with the world or with the environment means that trajectories will be generated. These trajectories means that an agent starts in a given state, execute an action, transit to a different state, execute another action, transit to a different state, etc. So, which is the goal of reinforced learning is to finding a policy that maximizes the expected return. This is a key concept. Which is the expected return is the discounted sum of the rewards. So the agent not necessarily want to maximize the short-term reward, but he wants to solve the task, and to solve the task means that he needs to consider the long-term rewards that the agent can obtain while executing this trajectory. Okay, so we want to maximize this expected return. The policy is not less that the way in which, or the function that allows the agent to choose for a given state which is the best action to take. And there is also the concept of value function. The value function captures also the long-term expected return when the agent is interacting with the environment. So when you have a value function, the optimal policy is the one that maximizes the value function. So you can apply reinforced learning using a value function or not using a value function. If you are using a value function, which is value-based reinforced learning, you will always select the action that maximizes the value. And if you are not using value function, so you have a parameterized policy function, and you will optimize the parameters of this function. How to compute the value function? The Bellman equation tells us that these value functions can be calculated recursively. So if they can calculate recursively, that means that you can incrementally approximate the value of these functions. So using this idea, you can develop the reinforced learning algorithms, and the most famous and used reinforced learning algorithm is called Q-learning, because it's used in the Q-value function. So you have, you can see there a loop, an algorithm with a loop, and in this loop, you can read that at each moment or at each time that the agent needs to take a decision, the agent chooses an action according to a policy which is related with the Q value. After choosing this action, the agent interacts with the environment. This interact with the environment means that the action is executed and the agent observe which is the next state and observe if it has a reward or not. After this, the agent had the information for updating the Q function, the Q that depends from the state and the actions. And these are the equations for updating the value function, and this equation is based on the Bellman equation. So basically, what the agent does while it's learning is to fill in this table. So you have this Q function that is stored in a table, and in this table, for each state and for each action, you have a value that tells you how good this action is. Okay, so through learning, you fill this table, and then when you want to make decisions, you just use this table. You are in a given state, and you select the action that gives you the highest value. Okay, this is the very basic idea of this basic reinforced learning algorithm. But using this kind of algorithms has a limitation. The limitation is that you have a table. That means that if you have many states and many different actions, the table can be very large. And in addition, if you have continuous actions, you cannot use a table. So which is the solution for that? The solution is not using a table. Okay? Instead of using a table, you will use a neural network for approximating the value function. And when you use a neural network for approximating the value function, then you have deep reinforced learning. So which is the main difference between reinforced learning and deep reinforced learning? That when you are using deep reinforced learning, you use neural networks for approximating the value function. If you are not using a value function, but if you are directly updating the policy function, in this case, you will use a neural network for updating or for approximating your function. So this gives, applying this concept gives this taxonomy of reinforced learning algorithms. Until now, all what I have said is about model-free reinforced learning. Model-free reinforced learning means that you don't have a model of the environment. So if you have model-free reinforced learning, you can approximate directly the policy function. And in this case, you have all these policy optimization algorithms. If you use a value function, you have these value-based algorithms. And all the names that are here are names of algorithms that are based on the use of neural networks, so are deep reinforced learning algorithms. It's also possible to combine and to use at the same time an estimation of the policy function and an estimation of the value function. And in this case, you have an actor-critic algorithm. In the actor-critic, the actor part is a network that optimizes the policy. And the critic part is another network that estimates the value function. So when you have an actor critic, you need two networks. okay? But if you read about the different algorithms, you will see that because of how this estimation process is implemented, you will need more networks, because just using one network, for instance, for estimating the value function, means that you will have instabilities. So you will use two networks, one network for the estimation and a target network for stability. So instead of using two networks, you will use normally 4. Moreover, for estimating the value function, you will need other networks, because you need to have a short estimation of the value function and a more longer estimation of the value function. So that means that very used algorithms as TD3 or SAC use 6 neural networks for the estimation. You also can use models, okay? And you have all this family of reinforced learning algorithms that use models, starting with a given model or also learning a model. I would say that until now, people prefer to use model-free algorithms because you don't need a priori knowledge. But now model-based algorithms are starting to be used because given that you are using a model, you can learn faster. Okay, so which are the challenges? One challenge is to choose the reward function. Okay, this is the only way in which you can tell your algorithm what you want to obtain. So how you say the algorithm to the robot, what you want that the robot learn is defining a good reward function. And it's also relevant, especially when you apply these algorithms in the real world, that the rewards and the states that you define can be observable. Okay, you have an observability issue, so in some cases you don't have full observability, and in this case you cannot use this MDP framework. You need to modify it a bit, and instead of an MDP, you will use a POMDP, yeah, which is partially observable MDP. But if you want to apply reinforced learning in the real world, which is the main limitation? The main limitation is that for learning you need to iterate, okay? But in this case, one iteration means one interaction of your machine with the real world. So in this case, you cannot think on thousands of interactions or of iterations, millions of iterations. You are allowed only to have few iterations, maybe dozens of iterations or hundreds of iterations. So this is a relevant issue, and now I will talk about this. So I will talk about how you address this problem and our experience by addressing this problem. So the first way of addressing this problem is using simulation tools. So that means that you learn in a simulation and then you apply in the real world. But you have a knowledge transfer problem because the simulation is not the real world. So you have a sim-to-real problem. But this problem can be addressed. I will present first a system that we built some years ago. I will give some details for navigation of these humanoid robots while playing soccer. Okay, so which are the constraint of this problem? So you will have a mapless visual navigation. So you will navigate based on your visual sensor, no map, no object detection algorithm, no object recognition algorithm, no depth sensor, so only visual. And also you have some constraints on the robot. So no GPU, a low-end CPU, and also a limited observability. The camera has only 60 degrees. In comparison, humans, we have 160 degrees in our horizontal field of view. So we implemented the DPG algorithm, which is an actor critic. So you have a network for the actor, a network for the critic. Given that you have low observability, we also control not only how the robot walks, but also the angle of the head. So the robot is able to move the head. And in addition, you put memory inside the network. So we put an LSTM layer inside the actor and the critic networks. Also, given that the robot cannot measure distance, cannot have a range sensor, we make a kind of trick. When we train in simulation, we provide this information to the reinforcement learning algorithm. So they use this information, and the algorithm learns how to estimate distances when using this information, and can use this when we apply in the real world without this distance information. So this is the basic idea regarding the reward function. We punish the robot every time that collides, and also we have a reward function that allows the robot to know how it's approaching the target. So here is some video of the behavior that we obtain. So we only use the camera information, and we don't have any visual perception algorithm that can detect robot or detect obstacles or recognize nothing. It's only this network that learns how to avoid the obstacles. Then we have a more recent application. This is the loading of material in a mining environment. For doing this, we build a special simulator that simulates the interaction between the bucket of this machine with the material that need to be loaded. And for testing this idea, we made a 5-to-1 scale of reality. We have a scale machine, and this scale draw points, which are the points where these materials need to be loaded. So this is the network. It's also an actor critic, and in this video you can see the different versions of the algorithms how are able to autonomously load material. Okay. Then we also address the problem of breaking rocks with these also big machines, which are these rock breakers or impact hammers. We also made a simulator, and we have in our lab a scale version of this big hammer. It's also a big hammer, but not as big as the one used in the mining industry. Here you have the network that we use. In this case, it's not an autocritic, but it's called DDDQN, which is double dialing DQN. It's only approximating the value function, and in this video, you see how this machine learns how to break rocks. Another idea, which is also very interesting, is to use human knowledge to accelerate the learning of these algorithms. So in this case, at the same time, you use your learning algorithm based on reinforced learning, and a human that give either advice or examples. And what you can obtain, if you look at this video, this game in English is Ball in a Cup. Is on the left side, you see the initial thing, what the robot is doing. At the right-hand side, you see the final behavior, which is able to completely solve the problem. And in the video below, you see the different trials. And in 70 trials, the robot is able to learn the behavior. Then it fails, but after starting on the 23rd trial, he solved completely the problem. So this very difficult problem, using this way of learning, allows a robot to learn this behavior only with 22 trials, which is much less than a human being. A human being need much more than this, okay? But the robot only 23. We also, sorry for a problem with the presentation, we also have analyzed which is the optimal way of mixing this when you have these two modalities of learning, reinforced learning at the same time, this human solution of the problem. And we found that the best way is to combine both, of course, but taking into account the agent performance. So when the agent is performing better, so you use more the reinforced learning solution than the human solution, and also we take into account for the training of the networks the gradients of the backpropagate signals, okay? And in this case, you have this other setup. You have a mobile robot. The mobile robot is moving between different points, and you can see that these people is putting them obstacles, and the robot is very reactive to avoid the obstacles after this learning stage and learning using the learning using the reinforced learning algorithms and also the information given by humans. So I think I have just 1 minute, something like this. Okay, I will skip this. In this case, this is not really this only simulation. We were able to design a system that is able to learn from scratch, so from knowing nothing, how to play soccer. The system also don't know at the beginning that he needs to make goals. But after a while, he learns to play soccer and to play as a team. My last slide, sorry, 1 minute. So what else you can do with reinforced learning? So which are the next ideas that the community is analyzing, and we are also working on this? I would say there are these 3 ideas. The first one is the use of causality in reinforced learning, or mixing causal models and reinforced learning models. So the idea here is to go not just using correlations between variables, but to determine which are the causal relationships between the different variables, and to use this in your reinforced learning algorithm. So normally you, at the first stage, make a kind of causal discovery and use this information in your reinforced learning algorithm. This allows to have a faster learning and also a transfer between different tasks, so that what you learn in one task can be used in a different task. Then you have these word models. These word models are models that the reinforced learning agent build and train, and these models can predict, given that the agent is in a given state, which is the next state and which is the possible reward. So it's like to have a simulator, but it's inside the agent, not outside. So it's like to have having imagination, and use your imagination to predict which are the outcomes of your actions, and using this learning, okay? And the third one is diffusion models. Probably all of you know that this is the state of the art for the generation of images, for the generative, for this. And you can use these diffusion models in different ways. One way is together with word models. So the word model machinery can be implemented using diffusion models. And the other way is something that I skip because of the time, is you can use offline reinforced learning, which means you collect data and then instead of interacting with the world, you learn using this collected data, but with diffusion models, you can augment the data that you have. So, as I said, people in this area is working in these three fields. So how to apply these ideas to have more powerful reinforced learning algorithms, so algorithms that can learn faster. So here's the name of some of the former and current students that have worked with me in all of these developments, and this is. Thank you very much.
Questions? Anyone? Rodrigo Salas has a question? No. Yes, yeah, okay. Actually, well, you know, this is super interesting. Yes? Actually, yes? No?
A new name, Rex.
Okay, awesome. I'm just joking, Rodrigo, if you're listening. Rex, he says, great talk. He is stealing my lines, eh? Great talk. With a view to real-world applications, one of the challenges of reinforcement learning often faces is generalization. Agents trained in a controlled lab setting may generalize poorly when deployed in a more chaotic real world. I was wondering if there was an issue you encountered, and if so, how you were able to handle it.
Okay, so the question is about generalization, and as in most of the machine learning-based algorithms, normally you build the algorithms for solving a specific problem. In the case of reinforced learning, also, you normally solve a specific problem. You want that your robot learn how to take objects. You want that your robot learns how to avoid obstacles, etc. Okay? So this is the usual way of addressing this problem. But at the end, I talk about causality. So the causality, or the use of causal models, is a way of going to this generalization. So if I am a robot, and if I learn to take this object, then I have partially learned how to take a pencil. And so I learn how to move my arm, how to grasp objects. Mm-hmm. So for going to these different applications, the current idea in reinforced learning is to use causality, because in causality, using causality, you learn of course, you learn cause and effect of your actions, but also you learn which variables are related with which other ones. So this is the current way of working towards generalization.
Yes, I think that the question had two parts, and the other part was also part of my own question, is what is your experience handling this transition from the simulator to the deployment in real life? Is there like any particular experience gained there?
Okay, so this is a relevant problem, and there's strategies. Okay, it's no general way of addressing this problem, but in some of the system that I described, the idea is that you work in a different domain, not in the. For instance, the algorithm doesn't receive the images of your camera, but for instance, you take the images of your cameras and you bring them to other domain. Could be, for instance, segmentation. Mm-hmm. Why? Because if you take a segmented image of the reality and a segmented image of a simulator are similar. Or you can, instead of having high resolution images, you segment them and reduce the resolution. If you make this in the two domains, then they look similar. So you don't have this sim to real problem. So, or in general terms, you can generate an embedding, okay? So you don't use your input data, so you use embeddings. And the trick is that your embeddings, the embeddings that you obtain from the real world or from simulation need to be the same. If you achieve that, then you can work in simulation and transfer to reality.
Very nice, thanks. Do we have any other questions? Yeah? Okay. Hey. So Rodrigo is asking, considering the use of reinforcement learning with human in the loop reinforcement learning, or human in the loop with reinforcement learning with human feedback in systems like ChatGPT, do you think similar techniques could be applied in the Chilean mining industry, in the Chilean mining, to enhance collaboration between human operators and autonomous robots? What specific challenges in the Chilean mining sector could be addressed through this approach, such as navigating in complex environments or real-time decision-making? It's a big question.
So this is a very general question, because in the mining industry there are thousands of different applications. So, but what I can say that in case of using autonomous machinery, okay, it's very difficult to solve many of the problems of the mining industry. So some specific problems. So years ago, people thought, okay, maybe in the future we could have a mine without person inside. This is not possible, okay? But a good idea could be a collaboration between autonomous systems and humans. So in robotics in general, there is a new area which is collaborative robotics. So you can use the collaborative robotics concepts in mining. So you can have systems that are autonomous, but when they cannot solve a given problem, they can request help from a human, and a human at a distance can help the autonomous system. So I think that the future of automation in mining is this collaboration between autonomous machine, teleoperated machine, and humans.
Yes, actually I can imagine the reverse scenario where the human operator is operating and the autonomous system interrupts him or her when he's about to make a mistake, like happens in cars now, no?
Of course.
The experience of Tesla with the autonomous driving is very similar to that, no? That when the autonomous driver diverges from the human driving, they generate a process to gather data and try to improve so there could be scenarios like that, no?
Assistive system for humans based on autonomous system, but also assistive systems for robots, and this assistance is given by humans. Yes.
I mean, I think we have to end here because we went like 20 minutes above time. But,
sorry.
It's a very interesting topic. So thanks Javier.
Okay. Thank you very much.
Thanks. Well, thanks. I keep, let's say, a secret competition with the presentations because Javier is the winner of the larger presentation, like with I don't know how many gigabytes because of the videos. And I am now going to present the runner-up in this competition. This is Yinoussa. It seems that the robotics people use a lot of videos, so with 1 gigabyte and something. So Yinoussa got his PhD from the University of Strasbourg in 2018, and since 2019 he joined Inria in the defrost team, and also became a lecturer in the University of Lille, and he is a full member of the FROST since 2022. His main research focus is in biomechanical modeling, medical simulation, augmented reality, and the modeling and control of soft robots for medical applications. So, thank you very much. Yinoussa, do you prefer this one? Or?
Thank you very much for the introduction. And I just want to thank Nayat, Luis, Stefan, and all Inria Chile teams for this great organization. I'm very happy to be there and nice. So I'm Yinoussa Adagolodjo and I'm assistant professor at University of Lille. Okay. This is our team, the first team. We are at Lille. As you can see, Lille is the heart of Europe. So if you plan to go to Europe, the first destination is Lille. Go to Lille before anywhere. Okay. So we are working on deformable robot, and we are according to the history of the team, we start working a lot on medical simulation, and like 6 years ago, we create like Inria project team. Like each 10 years, you have to change the project. So our team, we change the project. We go from medical simulation to soft robot, and that's why our application is mainly based on medical simulation. Okay. So yeah, this will be some kind of the pipeline of my presentation. Okay, I will talk a bit about medical simulation or biomedical simulation. Here I won't go into detail. I will present how we do the modeling of soft organs, and we use the same method for soft robot also. Okay. So for the biomedical simulation, what's very important for us is like how to find a relationship between, if I want to model the organ, an object or an organ, I want to find the relationship between the force or the load I'm applying to the organ and the deformation I get at the end of point. Okay, so that's very important to find what we call the constitutive law, which is the relationship between the constraint and the load. Okay, the constraint and the deformation. Okay, so for each organ, the first thing is to do the identification of mechanical properties. Okay. To find this identification, to find these properties, and then you use these properties to build your model. Okay. So in the case of soft tissue has like some kind of behave like nonlinear elastic object, but the thing is like we don't always have like the analytical solution. So what we use to do is like we use a numerical solution, okay, which is an approximation of the real solution. Here, the main method we use in our team is on finite element method. Okay, sorry. So we use finite element method, which has many flexibility, okay, precise for an approximation method, okay, and it's used in many applications like engineering and everything. Okay. So here, I will present some kind of pipeline we do when we do medical simulation. Okay, I want to go inside even when you see equations, the goal is not to present equations; it's to present the object. So for us, before starting the simulation, what we do, we start by doing the MRI image or the tomography of the patient. Okay, to get all the organs differently. Okay, here to get the liver, what's the relation between the liver and other organ. Okay, so we do the segmentation to get each organ. And on top of that, we use finite element method because we want to learn the behavior of the organ. With finite element method, we can't learn directly all the behavior. So we divide our domain in small domains, okay, which are very easy to learn. So we learn this behavior on each small domain, and after we gather all the results to get the behavior of the whole organ. So after that, what's also important is to find the relationship between the organs, okay? Like how my liver, if I want to learn the behavior of the liver, how my liver is attached to other organs, okay? So when I apply the load on the liver, how it's deformed according to the region or according to the other organ around. So the next step is now to build the equation, which is a very well-known equation, which is Newton's law equation, where we have here the stiffness of the material, here given by the elastic. The equation we talked about before, we have the damping to remove the mass and everything, okay, and this is the external forces. So we know that when we are building simulators doesn't work alone. Okay, so a lot of time these simulators are used to learn to teach practitioners to to master their techniques. So we always have like a person in the loop of the simulators. So like when I want to do the modelization between an organ and the interaction of people, so like this kind of equation is solved. Okay, so we have to go throughout these 4 steps. The first one is to find the deformation, okay, to compute the deformation of the organ. Okay. Find the collision between each organs, okay, resolve this collision and do the rendering for the user. And this, like, for each step, so this is what we solve in the simulation. For each step, compute the deformation, get the collision, solve contacts, then do the rendering. So when we have like a human in the loop, so the human interact in this stage, okay, the first one is the one who creates the interaction, so he's at the collision detection part, okay, and for the feedback, we solve the contact, we give the feedback, the force feedback to the patient or the user to know how it touched the organ. Okay, so now I will show you how we use the same algorithm in the medical and the augmented reality in the operating room, okay? So I will take the example of like hepatic surgery. In the hepatic surgery, when the goal is the standard goal for when we want to do the operation for the tumor, to remove some kind of tumor, when the tumor is like larger than 4 centimeters, okay? We use the standard goal is to always open and go and cut. That's all. It's easy to do, okay? So the thing is, the principle is that you start by doing the MRI, the tomography, okay? This is the process they are doing in the today, okay? You do the segmentation to find each organ, okay? You do the reconstruction to get the organ, vessels, arteries, and everything, okay? So in the operating room, what you do is like you don't have access to MRI, you don't have access to tomography, you only have access to ultrasound. But the thing is, the ultrasound is very noisy, so like we have like difficulty to locate where is the tumor. So what you do is you take the reconstructed image you already built before, okay? And you do some kind of mind mapping between them and say, okay, this is approximately the position of my tumor, okay? So we have something they call surgery resection paradox, which is I know where is my tumor. I want to cut larger to be sure that I take off all the tumor, but I want to keep enough artery, like much artery, to be sure that my liver still works like it have to work. So this is very difficult to do. For us, we propose a new solution to the surgeon to say, okay, we will take this reconstruction image you already built before, okay? We will build a mechanical, we do the simulation on top of this image, okay? So we build a mechanical object on it, and our goal is to do the augmented reality, some kind of digital twin, okay? So to map the real organ, and to map the model, the numerical model on top of the real organ, okay? So this is what we did at Paris, in the operating room. Here, as you can see, directly the surgeon can have directly the good vision of the position of the tumor, okay, which is very easy to cut at that point. Okay. So yeah, I will just show you the video. So before, here I'm showing the image of the real patient, but before that we did it on phantoms. We have accreditation. We go from phantom to animals. After the animals, we do it on cadaver. Before do it on this guy. Okay. So I forgot my animation. So now I will talk about another part of our work is like based on the surgical robot. Okay. According to what we just present, I told you that they use open surgery when the tumor is bigger than 3 or 4 centimeters. But sometimes the tumor is very small, and even before the surgery, you have to do the biopsy, okay? And the biopsy involves needle insertion, okay? Like this here, you have to insert the needle going by the skin, throughout the skin, and go to remove a piece of tissue to test to be sure that this kind of tumor are malign or not, and it need operation or not. And sometimes when the tumor is very small, you just want to kill it directly by doing some kind of cryoablation or by doing oven, okay? So this process involve mainly needle insertion throughout the skin. And as you can see, this is a kind of test they are doing to remove to do some kind of biopsy, but to do it, they inject the solution and make this region more like visible before remove this kind of tissue. So since the procedure is very long, okay, people say, okay, instead of just doing it manually always, or to have the surgeon do it, we can assist surgeons with robots. So we have like this kind of robot where we attach it directly to the patient, and then the robot can follow the briefing, okay, and remove the problem of this movement of the liver, and just go to do the biopsy, okay. But the problem is not only the displacement of the patient, like it's not only the movement of the liver, but it's also due to the fact that we are using like thin needles. So when we start doing insertion, the needle deform and the organs also moves. So we have to be able to take into account this deformation coming from needle and the tissue, okay? For that, we try to propose a new solution for that to say, okay, we already have the biomechanical simulation, okay? We know how to learn the behavior of organs. Why we don't include this kind of behavior inside the controller of the robot, okay? So my robot will not be moving, doing visual surveying, but I anticipate the deformation of the organ, anticipate the deformation of the needle, to be sure that I will get my target in one shot. Okay? So for that, we propose a new solution. Okay? This is what we have here, like to say, okay, instead of doing this, we will have to do the insertion following a trajectory inside a deformable object in order to touch some kind of things, okay? So here, the algorithm we are using here is the same we use on the patient in the hospital, the image I showed before, okay? So there, we show that we are able to follow this kind of trajectory while we are inserting inside the deformable organ, where the needle is deforming and the tissue is deforming, okay? Huh? Okay. So yeah, I know that you want to take your coffee, so I'm doing faster too. So this is the last part of my presentation. It's like now that I show that we can use the medical simulation to do the augmented reality, to bring information to the surgeons in the operating room, to use it to guide more the robot during the surgery, okay? The last step is, okay, why we don't, like when we try to go to the hospital and bring this kind of robot in the hospital, like surgeons just say, it's very difficult for us to accept this kind of robot because you have to place it in the operating room, you have to change all the process in the operating room, very difficult to do, and this kind of robot, like the interaction with human is very difficult, so it's very difficult to adopt this kind of robot. So the next generation of robot is like to have like this kind of robot inspired by the nature, okay, software, which can like work well in the confined environment and interact very well with people, okay. So like, and as you can see, this kind of robot are built with deformable structure object like silicone or metal structure, okay. So very easy to integrate in an environment where you have people, because when you are in contact of this kind of organ, this kind of robot, the robot deform, but you don't have, like, you are not injured. So for us, we say, okay, that's a new generation of robot. Maybe we can bring it directly in the operating room, okay? And as you can see, you already have some kind of application using it in the medical operation. But the difficulty with this kind of robot is the fact that they are deforming. So here we have like an infinite number of degrees of freedom, okay? So not easy to model compared to the old robot, like the rigid robot, where to know the position of this rigid robot or the position of the end vector, you have just to know the position of the geometry and the position of each angle. For with this rigid soft robot, it's very difficult to do. So we go back to our old method, which is finite element method. Say, okay, these robots are built with the same structure like organs, so we can use them. We can use the same method to model them. Okay. But the things we also discover is the fact that this robot depend a lot, like the cinematic of this robot depend a lot on the material we use to build them, okay? So, like, as you can see on this image, if I have a different structure, when I apply the same actuation, so I don't have the final deformation are not same, okay? So we have to integrate this, the behavior of the structure inside the modeling of this kind of robot, okay? So we also, as I also said before, these robots deform when they are in contact with their environment. So we also have to integrate the contact, the notion of the contact inside this modeling, the modeling of this robot, okay? So as I said, the robot have to behave like the nature. We have to take the inspiration from the nature. So for us, the challenge, we have many challenges. The first one is like how to model well this robot, okay? How to to help them to navigate in complex and confined environment. How to let them manipulate fragile objects, okay? Because here, as you see, the octopus is softer, but it's also able to apply force when it needs, okay? So for us, we need to be able to model this kind of robot. And also integrate sensing, because the robots are interacting with the environment. So we also need to integrate the sensing inside this kind of robot we are building. For the application, I will just switch to this application. This is the first project I worked on when I joined the defrost team. Okay, here you will, where we target like the heart disease. For the heart disease, you have two kind of heart disease. The first one is like, I can't hear you, but with only hear aid, we just attached it to this bone, and this will transfer, give you the information. But the second part is like people who are not able to understand anything anymore. So there, you need to do the operation and insert, and cochlear, we call it cochlear implant inside this cochlear, okay? And the size of the cochlear implant is like only 24 millimeters, but with a thickness of 20 micrometers, okay? So it's very tiny and very difficult to place, okay? So during, and what's also important here is like the configuration of this cochlear implant is very important, because in our bones inside our ears, like we have different kind of signal we are able to translate, okay? So it's very important to be able to give the same signal to be sure that we are giving back the earth to people. So here, what's happened in real life when they do this kind of operation is like, due to the friction, we have this kind of problem where the cochlear implant is not really attached to the cochlea, okay? Sometimes it happens that we have the friction, so we have this kind of information, or sometimes you just have like, you think that you really insert the cochlear implant, but the problem is like, at this point, the cochlear implant just break up like that. So at the end, the thing is, you have to do the second day of the operation, you have to go to do the CT scan, and when you do the CT scan, you just see that, okay, it's not well posed, so you have to remove it and do the operation again, okay? So it's not very easy for the patient. So for that, we are in this project, what we think about is like to have like this kind of active soft implant. This active means that we will add actioners inside the implant. Okay, we attach actioners inside to this implant, and this actioner will deform the implant when it's made. Okay, so it will be some kind of smart implant according to the contact it's having with the wall of the cochlea. This implant will be able to know when he have to deform itself. Okay. So yeah, in this project, that's what we try to do. And instead of just letting people pose them make it, to let the surgeon pose it. We just say, okay, we can integrate the robot in the loop. So we have we already have the information about the size of the cochlea. Okay, we can reconstruct the cochlea. So we can use this information to know how to displace the robot. Okay, and to well pose this cochlear implant. And the first thing we do is we do the simulation, the patient-specific simulation to know which angle to attack to do the insertion. So according to your, we don't have the same size of the cochlea when you are a baby or when you are adult, and with male, female, we don't have the same size. So according to your size, according to your morphology, we adapt this kind of insertion by doing the first part, which is doing the simulation. And on top of the simulation, then we can choose which cochlear implant is adapted for you. So then we do the insertion. Okay. Okay. So here, this is the last project that we work on, but yeah, it's just the same for the navigation in the intestine, but it's not an important domain. Okay. Thank you very much.
Thanks. This is, super interesting. Like a very different take on robotics, no? Because it's soft and SOFA is one of the, we tend to reduce the conversation when we talk about Inria software to scikit-learn because it's very famous and all of that. But SOFA is one of other jewels from the crown of Inria softwares that are heavily used in medicine, for example, as you showed. So it's very interesting to see. Do we have any question from the room? Yeah.
Hi, I'll make it brief. I wanted to ask you what kind of limitations do you get from the real-time requirements? Because I imagine that you're having to use a much more coarse mesh, a much more simple simulation to be able to do a real-time simulation. So what kind of limitations do you get from there?
From the time computation, right?
Yeah.
For the time computation, sometimes we just try to find the trade-off between a good solvers and the meshes. Okay, you say, okay, I want to have a very realistic simulation, but my realistic simulation is very time-consuming. So what we do is sometimes we decrease, okay, the size of the mesh, or we reduce instead of using nonlinear solvers, okay, we use nonlinear elastic model. We use linear elastic model by adding some tricks, geometrical tricks, to be sure that we are still close to the reality, but we are still close to the solution, but not losing. This is all the things we can do, and we have the limitation of the computer today. So, and sometimes some algorithm we can't do the parallelization, so you have to find some kind of tricks to. But mainly we are using GPU, but we do also change the solvers.
Thanks. Awesome. Well, I have let's say it's more a curiosity than a question. Seeing the SOFA simulations, are you able to also simulate the fluid inside the body, or are just solid parts interacting?
Yeah, we are. You have in SOFA you have plugins for simulating fluids. Yeah. But the thing is, for us, I'm not showing fluid here because, as he said before, we have problem of time consuming. So when you are doing the modelization of the fluid, also you have also spend time to do this kind of modelization. So we used to remove it when we can, it's not very important.
Awesome. And my other question is more or less the same as before, no? Related to soft robotics, has it been challenging to move from the simulation to the real life, real world deployment? Because I understand that you do it all the time, no?
Yeah. it's very it's very difficult. We always face some problem you didn't imagine it during the building, okay? And as I said, these algorithms are the approximation of the reality. So sometimes it's very difficult to get the good parameters, physical parameters, to be close to the real robot behavior. So yeah, that's why we really need to embed the electric sensors inside our robot. So with sensor, we can do some kind of closed loop control, which reduce a lot the difficulty of this simulation.
Awesome. We are completely out of time. So let's take, well, thank you for the presentation. Let's take 15-minute break. 20, no, 15, no. 20 minutes break, and we get back to continue with the end of this session. Thank you very much. Well, thank you. Let's continue with the two final presentations for this afternoon. The next presentation is by Sebastián Gallardo. Sebastián is an informatics engineer and master in computer science from the Universidad Técnica Federico Santa María. He worked in different projects in Chilean universities as an engineer during his master studies. And since a couple of years, he started a PhD in Inria, Université Côte d'Azur. He has been working in topics related to newspapers, aesthetics, and his presentation is going to be about this, and the title is a clustering-based article template recommendation system for newspaper editors. So, Sebastián, the floor is yours. Thank you very much.
Hello. Okay, thank you for having me. I'm really pleased to be here among other really amazing researchers presented before. So today I'm going to give you a talk about my latest project working for my thesis in France. That's called a clustering-based article template recommendation system for newspaper editors. First, I just give you context about my thesis, because my thesis is not exactly that project only, but it's called Making Newspapers Layout Dynamic, a study of a new combinatorial geometric packing problem. So, well, you can see the names of my supervisors. And something that is really important for us is that it's funded and also is made in cooperation with a company, an illusion partner, that is called Adagolodjo, and Melody is their software, that is basically a newspaper CMS, but a really powerful one. So, well, I started last year, and what I'm doing is basically, well, I can summarize in 3 basic applications. That is basically a layout exploration of the newspaper. So, for example, you can see, for example, that you can actually, from New York Times or any newspaper, rearrange it for different purposes. My team is specialized in low vision problems. So one of the applications is to improve readability for people to have low vision problems. For example, the second application. But today, I'm going to focus on individual articles, in particular the template that you use inside a newspaper. So let's get dig a little bit in this. According to our partner, their experience among many years, before, when we didn't have the web versions, that means the digital version of the newspapers, the pipeline to actually assemble a newspaper and an individual article was the following. It was called layout-driven, that basically you select first a template for an individual article, then you assemble the content inside, the title, the body text, the images, etc., and then you obtain your final article. But today, thanks to of course, to the digital channels, it does in the reverse order. That means first you write the content, as fast as you can, you have to put it in a web version to be state of the art, well, of course, the globalization allows to have really big, fast news and Twitter, etc. And then you have to search for a good template to go for the print version. That's still an interest for the companies because it's still there are some people that read, and since now there are less people that read print newspaper than before, it's getting more costly. So we want to make it as efficient as we can. So we have a new use case in this case. That is, we can summarize as this. As a journalist, I want to quickly select the best template for the article I choose to write, so that I can put it into production efficiently. And here is where I enter with the project I'm going to explain now. So basically, we have these challenges as this journalist. The recommendations, and this is really important, should be relevant to the article content, but also diverse in structure. For example, if we propose only a square templates that has 2 images at the top, and we have 5 examples like that, we're not interested in that. We try to promote diversity of the examples that we get. Also, we are trying to propose templates that are quite unpopular, not the ones that people always use. And also another problem that is there's a lack of articles templates datasets, because it's a really, as you say, a specific problem. So we make the following contributions: a recommendation framework focused on template selection, a novel clustering-based approach that maximizes novelty and diversity related to popularity and the diversity respectively. And well, the other two, of course, that I'm going to explain you now. So basically, this is a meta overview. We have our input, that is the catalog of templates that can be as vast. In our case, we have close to 500 templates, for example. Some requirements. For example, the user wants to, I don't know, write 200 characters, a title, 5 images, etc. Some requirements, and an historical usage of them, how much they were used before. We're going to pass through an offline phase, an online phase, and we get to our input. So I'm going to explain each one of this step. I'm going to focus first a little bit just in the catalog of templates because it's not trivial how we annotate this, how we segmentate this. So basically here you see what is for us a template. You have on the right, you have the rendering, that means the real newspaper image that represents the template. And you have an abstract version, an abstract structure in the left that we made from scratch. We start with the XML versions of the templates, and we generate a JSON that cleans all the things that we don't care, and also segmentates each one of the parts as a polygon. So you see, for example, here, you have the body text as a polygon there, you have images, captions, etc. So our input is, of course, the structure, the abstract version. And well, there you see like the text version as a JSON. It's easier for us to treat. So now I'm going to dig into the offline phase. So okay, first, why clustering? Since we are really interested into the diversity, our idea, and we came with this basic idea of first cluster the templates based on some similarity measure, and then select 1 or 2, or as you want, templates per cluster. So in that case, as you see, it can be quite obvious that you see that you don't, all the similar templates are together. So it's quite easy to actually select templates that are different in structure. But for that, we need a similarity measure. So how we can do this? The most basic one, it can be an intersection over union metric. That means you put both templates together, and you see how much area you overlap. Okay. In this case, it's not as easy. You have to compute a custom base because you have several elements. So what you do is actually this: you assign for each one of the elements in one template another element in the right template in this case, and you compute this custom IOU that can be as complex as you can. In fact, we use something that is quite state of the art instead of using a standard IOU. And then you can average that and obtain an intersection or union-based measure for the similarity measure. But even if you do this, this metric has some problems. The most important one is the sensitivity to elements misalignments that preserve the structures. For example, if you, I don't know, the caption that you see in green in the bottom part, if you misalign a little bit, or you put it in, I don't know, with a different, slightly different position, you'll have 0 IAU because they're not aligned. And that can be a problem because actually the structure are quite similar. So we want something, we want a similarity measure that actually measures the similarity in terms of the structure of the template. So we came with the idea to modeling the templates as a graph. So here, for example, you have a graph. The color measures, in this case, indicate the class. That means if it's a title, if it's an image, it's a no. And you have a complete graph with some relationship between them. Here you have the actual formal definition, but for the lack of time, I'm going to continue with this. So after that, you can actually compute a distance between graphs. That means you have 2 graphs. We're trying to measure the similarity between these 2 graphs. This is not something new. This is something that was done by another, what you see the references there. So we took into account their methods, and we apply it in our application that we want to use it in our framework. Basically, what you're doing this is for 2 graphs, you're using attention-based weights to compute an embedding of each one. So you see, you have the embedding at the top as a vector, and that embedding vector you can compute any Euclidean distance as you want. But the novelty of this method in particular is that you also have cross-graph communication before the embedding. So you learn even more in this case, instead of computing individual embeddings of each template. So we implement this for our data, for an augmented version of the data set, to have as many templates as we can. And we train using pairs, because in this case it's a supervised approach, so we need labels for each pair or for each triplet. We use our custom IOU that I explained you before. If you want more details, of course, you can always go for the full report. But we use that custom IOU by symmetric to weekly label the pairs and triplets and then go into training. And of course, the distance in this case is going to be the absolute value of this of the output of this graph matching neural network. It's absolute value because it's always negative. 0 means that they're exactly the same graph. So we took the opposite to have a distance measure. So after that, we use that similarity measure to obtain an agglomerated clustering. An agglomerated clustering, for people who don't know, is simply start each template, in this case, as an individual cluster, and start merging clusters based on if the average distance, in this case, distance based on what I showed you before, is below a certain threshold. In this case, is indicated by CTH. So with that, we obtain something like this. As you see, it's an example. Of course, the size of each ball in this case is regarding the usage of the template. So a bigger one means that it's a really high usage template. But there are clusters based on similarity between them, structure similarity, not based on usage, as common methods for to do this do. So now I can explain you a little bit the ordering phase. Basically, we base this on the cluster paper that is there, that actually also does a clustering and then select for each cluster. But, well, I'm going to explain you after in the results part what are the differences with our method. First, we assign the usage. That means the size of the balls in this case. Then we filter based on our requirements. Remember that we have requirements for each template. So we filter, and we can only use now as an output the green templates in this case. Then we initialize this something that we use the same name as cluster paper used, cluster weights. That means how many templates we can use per cluster. We initialize these values by simply, in this case, in this example, we want a top 5. We want the top 5 templates for a certain requirement. So you see, we select the top 5 biggest templates, in this case, the biggest elements. And then you see we are going to use 3 for cluster 2 and 2 for cluster 3 because we have 2 in cluster 3 and 3 in cluster 2. But then to improve diversity, that's what we want actually, we want to reassign these cluster weight values to promote diversity. That means we want to explore the other clusters. So this is really simple also. We are going to loop over this over the clusters until we reach that for all the clusters, we have a limit of 2, in this case, templates per cluster. This can be tunable. It can be 1, it can be 3, as you want. In this case, for this example, we're going to use 2 as a threshold. That means cluster 2 is violating this constraint. We need less. So we want to move, that means diminish and augment the cluster weight of cluster 4 or cluster 1. That are the possible candidates. Which one we select? Well, this is a novelty of our method in comparison to others. We are going to select the farthest one, because the farthest one gives you the biggest local diversity. That means, for example, cluster 1 have templates that are more different to cluster 2 than cluster 4, that is closer. This is something that before wasn't considered, and in fact, it was told that it's not a big deal, but we found in our results that it's actually a big difference. So in this case, cluster weight 2 is going to be 2, and cluster weight 1 is going to be 1. Okay? And finally, we have here another novelty, is that we are going to select based on the cluster weight values, updated cluster weight values. That means 2 for cluster 2, 2 for cluster 3, and 1 for cluster 1. But we are going to suppress the ones that are really similar to the ones that we already select. So for example, we're going to select 1, that is the biggest one first, but we're going to suppress the other 2. Then we're going to select 2 that is in cluster 3, but we're going to suppress the other 3 because they're really similar. That means they're, in this case, represented that they're closer. So with that, you can obtain actually the output of our top 5 list. So now I'm going to show you a little bit some results, quantitative, and also some examples. The dataset we use, we created a dataset of 452 templates coming from real newspaper publishers. We extract information from real French newspapers that the company allow us to use. And each one, as I showed you, represents as a JSON file, and also the usage as a CSV data. And this data is publicly available for further researchers if someone wants to explore even more this topic. So we compare against the simplest method that is most popular. That means just select the top 5 most popular ones. The classic cluster, we call it classic. That is the cluster from the paper. That basically they use also clustering-based method, but the cluster based on usage. They don't use any similarity measure, and also they use the size of the recommendation list as the number of clusters. So, for example, if you want a top 5, they create five clusters on real time, instead of our case that we have pre-computed the cluster based on a similarity measure that doesn't consider any parameter apart from the threshold based on the similarity measure. And an adapted cluster that we implement, that is basically an adaptation of cluster, but that does not have the distance between cluster notion. That means if you have 2 candidates, you select neither of them. And you don't have also the local suppression, because we want to see how much impacts these two characteristics. And this is really important. We are considering as evaluation metrics accuracy, of course. That means how is the rank order that you obtain in comparison to the most popular. That's to measure accuracy regarding popularity. Novelty, that means we want to check the popularity bias. In this dataset, it's a really, really long tail. That means we have 90% of the templates have really low usage. So we want to see how many templates of that long tail we are using. And that's something critical for this application. In this case, we have this limit. Of course, there is a reason for that. You can check the report for more proof of why we use that value. And most importantly, for us, is the key feature is diversity, the average distance between all templates in the recommended list. And also another scenario that is really interesting that is that we are also considering the differences by different distributions of the usage. The usage is still long tail, it's the same distribution, but what happens, for example, if your top 5 is in one cluster, as you see in the right example, in comparison to another example, that's, for example, your top 5 is distributed among the clusters. One can think that the left one is quite easy for any recommendation system, because if you go by popularity, you, by luck, obtain diverse templates. But what happens is your most popular ones are together. So we want to explore that, and we construct a distribution, a synthetic distribution, to try to use both scenarios. The left one is how actually the data is, and the right one is something synthetic that we use, that we create to test what happened in this case. So as you see here, diversity increased a lot. Well, first let's see the original data distribution. There is not a big change in terms of diversity. There is a slight increasing regarding the local suppression mechanism. But for the one that you have clusters that has the top really located in one cluster or in few clusters, that can be more challenging. And you see that our method actually increased a lot the diversity. So we really think that it can be a state of the art in that sense. Of course, there is a common in recommendation system literature, a common trade-off between accuracy and diversity. We lose a little bit of the accuracy because of that, but we're still in the same order of magnitude, and also it's a trade-off that we want to account in this case, because for this application, for our company, it's something that we prefer to have diversity that accuracy in terms of popularity. And finally, the long tail percentage, of course, since we are promoting the usage of low popularity thanks to our local suppression mechanism, we have a big increase. Finally, I want to show you some examples, real examples. So, for example, the most popular algorithm gives you this top 5 for a query that is top 5 templates with a title and no images. I'm going to show you this example because it's the easiest to illustrate, but you can use any query as you want. And the classic closed deep also have the same example, because as it does not cluster based on similarity, there is no reason to think that it will get a different example. Maybe yes, but it's going to be quite log and not really a feature of the method. So it's not really unfair to compare against them. So let's see what happened with the adapted closed deep. That's actually more fair because it clusters based on a GMN measure. That's the one that I showed you before. So in this case, you see a difference. You see, for example, that you're using your top 3 now. Before it was a top 4, now it's a 3, and you eliminate the top 3 here because it's really similar to the first one. So you don't really need it now, and you can replace it, for example, that is long one. Ignore, of course, that is a really weird shape. It's just to show you an illustrative example. And well, you complete it with the last one that is also different to the other 3. But our method went even further. By, for example, in this case, the first 2 are quite different. Well, they're quite similar, really, but adaptive closed deep thing that is good to promote both. Why? Because they're both popular. You see the usage below. Our method, thanks to the local suppression mechanism, decides that no, it's too similar, so we're going to promote the usage of another one. So it selects the white one that as a top 2 you see there. It's of the same cluster, it's less popular, but it's more different. And also, in this case, you see that this distance between cluster notion decide to use also a cluster, a template that is really different to the other in comparison to adapted cluster. So as you see, we show presented clustering based on your system, designed to promote diversity in template recommendations. Our method demonstrates significant improvements to the literature and similar methods. Especially in scenarios with high-rated items are concentrated within a few clusters. That's something that wasn't taken into account before. So what's this ongoing project, of course? There are 2 main things that I want to finish with this. First is that the implementation as an API for Melody, because we want to conduct user studies with real clients in the company. This has been a little bit delayed because of company problems with some other priorities in the other softwares. But it's something we want to account to actually have user studies that show that our method is better in that sense. And again, I show you my thesis-like overview, because all of these things that you see, the clusters or the recommendations, can be used in my main focus, that is to explore the layers. For example, one can think, okay, what happens if we replace one article with another, with the same article, but with a different shape, with a different template? How do you redistribute this? So it can be a really good input for the method. That in fact is something that I am already developing and is quite advanced. That is a local search algorithm that plays with this as a bin packing problem, because of people who are on that topic. Is a local search procedure to actually explore different combinations. Is this 2D layout? So it can be something really useful. All of this work that you see now for my main thesis project. Thank you all.
Thanks, Sebastián. Very, very interesting. Do we have questions in the room? Go ahead. Mike is arriving.
Thank you for your presentation.
Thank you.
I understand that this work with one article, but do you have some method to incorporate the considering the others articles in all the newspaper?
I mean, yeah, that's a really good question, because actually, if you change one template, for example, one other one that have different dimensions, it will impact all the others in terms of tracking. That's why, in fact, I start this project by with the whole newspaper, and I'm treating the whole newspaper as an optimization problem, a combinatorial optimization problem. So I'm exploring it as a packing problem. That means, for example, what happens if you have I don't know, your templates. Your newspaper. What happens if you rearrange them in a different way? And I'm measuring in that case the objective function in that case is for example, the aesthetics of the newspaper, or in the application that I showed you about magnification, the readability, how many lines you have, for example, for the headlines. So in that case, I'm pursuing a different strategy and a different objective, because I don't want to replicate templates. I want to explore new ones. So, but now in the future, in the near future, what I'm trying to do is to apply this technique that I use for articles, now for the whole newspaper. In a sense, for example, you see that I measure similarity. What happens now is if I measure similarity of the whole newspaper, and I use that, for example, as part of my objective function to explore quality of the layouts. So my idea is to use different techniques that I learned here and I use here for the whole newspaper. But in summary, it's not the same goal that I'm pursuing. Here, I'm trying to pursue a system to obtain the best templates in the case of a data set I already have. For the case of layouts, of complete newspaper layouts, I'm pursuing to explore new ones. So it's not that I'm going to apply directly this, because it's not the same goal. But I'm going to apply techniques from here. I don't know if that answers your question.
Yeah, over there.
Hello, that was a very nice presentation. I would like to know if there are any limit cases, like, for example, I don't know, the templates, I think that must have some kind of limit of characters, for example, or the content that it can contain is limited by the size of the template. So are there any limit cases where the user may misuse the system that you're developing and, for example, have a text that's too long to fit any template of the ones that you have, and how can this problem be addressed? Because it is not only about how to choose a template, but also what to put into it. And also, I have another question, kind of related. Have you explored any relation with large language models or these kinds of tools that also interact with the text that you want to use into your template?
Thank you. Really good question. Actually, it's something that it's a common question in other presentations that I had before, because it's not quite trivial. Regarding only this method that you see here, the admissibility of the templates, that means the templates that you saw in green, are only the ones that can fit the content that you're trying to do. So that's a first filter. But actually, in real life, in the real life application of this, that is something that we are actually almost in production, because it's something that I am implementing. In reality, the CMS melody, the one that I talk about, has a way to measure, for example, if you have a little bit more content, it will be enlarged a little bit. If you have less content, it will diminish a little bit, but with a certain tolerance. Of course, if you put a lot of content, it will not fit. So it will tell you immediately that you cannot. Currently, there is no recommendation system, so it's just giving you any template that can fit. This system, of course, is going to improve that. But here I'm showing you as a hard constraint, but in reality, it's quite a soft constraint, until with a certain tolerance, of course. So you have that tolerance. Also, another interesting thing that we are trying to address, we're not really sure, because we have to speak with the company to see what are the limits, is that, for example, you can have, for example, if you have a template with 4 images, you can actually write an article with 3 images and replace 1 image with more text. So you can increase the amount of text that you're using. That's something that actually you can do in Melody. So it's something really interesting to do. So we are discussing with the company what are the limits of that for us in this system, because if you cannot do anything, basically anything can be admissible. So we have to check tolerance, of course. For example, for admissible templates, we're going to consider the ones that have exactly the same number of images, and maybe the ones that has more images and allows for more text, and play with that a little bit. But all of that is, at least for now, in the current state of the algorithm, of the method, is for the admissibility, for the filter in the beginning. Then the algorithm can run as it wants. And your second question about LLMs. I'm not sure about how to apply LLMs here because I'm playing with the layouts, not with the content. In fact, my thesis is about the layouts, not the content at all. Of course, what I explore, because I'm reading a lot of state-of-the-art methods to do layouting, I'm more a person of combinatorial optimization, something similar to what Professor Elizabeth presented yesterday. So I'm not really into a lot of LLMs, but for this topic, I have to explore, I have to read. And I read some transformers ways, for example, transformer application to layout. It's a method, in fact, called layout transformer, if you want to search about it. There are also variations of autocoders, GANs to do layouting. But I haven't found anything related to this kind of layouts. In general, are for example, for posters. For example, you want to do a poster for an advertisement in the street. I read a paper about that. There is also one about user interface that's slightly different. But I haven't found anything exactly like this. But of course, it can be applied. Of course, it are related topics. So it's something that I have to explore. But since I'm always looking for exploring new shapes, new ways to optimize the layouts, I always go into the direction of local search, more that direction. So I'm dealing with try to have something maybe hybrid that can use both things.
Thank you very much. We are running out of time, so I have many questions. Maybe we can talk later or tomorrow. But my intuition is that maybe the template is influenced by the text it's expressing. So in that sense, I think it's the idea that maybe you can use some multimodal approach where the template is also biased by what you want to express. If you want to say crisis, maybe you want a template that is more, dramatic, or
actually that is true.
If it is illegal thing, you can want to make it. I don't know, but just an idea.
Yes. Well, we can discuss after about that. Yes.
Let's talk about it later. Thank you very much.
Thank you.
Please. Well, and the last presentation of this session is by Sofía Callejas. Sofía is a researcher at Inria Chile. She is also an electrical engineer from Universidad de Chile and has a master in engineering from the Centrale in Lille. And she's going to be presenting some of the work we have been doing related to understanding the ocean and climate change, in particular one related to plankton recognition. So, Sofía, welcome.
So this works, yes. So, hello everybody. My name is Sofía Callejas. I'm currently at work in Inria Chile. I am a researcher. So I'm gonna present you what I'm working on. So the title of the presentation is capturing the essence of plankton and long-tail problems. So let's go with the content here. So first of all, I'm gonna introduce you what is Oceania. Then I'm gonna present you the background a little bit, the state of the art, our contribution of this plankton image recognition, and then the classification and then the model that we develop for this kind of data set, then the explainability analysis, and finally the conclusion and future work. So let's start with it. So first of all, it's important to explain the challenge that we have here in Inria Chile, that's called Oceania, because this challenge takes in plankton image recognition. So what is Oceania? Oceania uses artificial intelligence, machine learning, and modeling for understanding climate change. So now, for that, I have a question now, because what is the relationship between the ocean and climate change? Why wasn't this project called, I don't know, Tree CA, Nature A? That is a really good question for that. So for two main reasons. The first reason is the oceans act like climate safe regulator. Because to warm all this water, we need a lot of energy. And the second reason is when in the ocean, we have a lot of biodiversity, particularly plankton, and plankton absorb more CO2 than all the Amazon complete, okay? That all the Amazon complete, so that is the reason that it's important to take care of plankton. And first of all, we have to identify plankton. So for that, we're going to use image. Why image and not genetic sequences? Because for genetic sequences, it's so expensive. Because we need an expert, but not only an expert. We need an expert in plankton species. And the most difficult part over here is for each expedition, the expert use different scan or cameras for plankton images, and the processing and the quality of the images will be different. But unfortunately, we have EcoTaxa. EcoTaxa is a tool for taxonomic plankton identification, and there we can find more than 320 million images, and around 4 million images taken as living, and around 8 million images taken as not living. So there we have a lot of information, and we have to use it. So now I'm going to explain you a little bit some of the benchmark dataset that we have in the literature of plankton identification. So the first dataset is called HUI. In this dataset is located in the United States. And we have more than 3 million images there, and these data have 103 classes, and for SUSCANNet is a subset of EcoTaxa, the tool that I mentioned before, and it is located in France. We have in this dataset more than 1.4 million images, and we have 29 classes. So now here, these two graphs are very important because it's the distribution of both datasets. The sample of the dataset is important to say samples of the dataset, and here the most important in this graph is the scale that we use, because the scale is logarithmic. So we can conclude here that this problem is a long tail problem because we have a huge imbalance in both of datasets. So now I'm going to explain you a little bit the state of the art that we have now. So some experts have already used deep learning approaches for plankton identification, like visual transformers and convolutional neural networks, but these researchers relying on small datasets and subset of the data that I mentioned before. For example, here in this table, I know that it works. No, for example, here in this table, in the number of samples, it's not a lot. We can see here. And also, the first dataset that we have here is a subset of the dataset that I mentioned before. For example, HUI 22 is 22 number of classes, and HUI 40, I'm sorry, is 40 number of classes. So our contribution, so what do we want to do? So we want to use the entire dataset because it's very important to use entire dataset because we want to represent the unbalanced distribution in plankton images, the unbalanced distribution in plankton species in natural environment. And also, for the challenge, Oceania is very important, the explainability part. So that is the reason that we applied some GradCAD techniques for that. So now I'm going to explain the model that we developed. So we use pre-training model for that. We use three pre-trained models based on convolution networks, and 2 models based on visual transformers. And we use also for the data augmentation, we use 2 techniques. The first one is basic image manipulation, is flip, horizontal flip, vertical flip, and translation. And for the other data augmentation that we use is random augment. And this one depends in 2 parameters, in n and m, and n is the number of the argumentation that we want to apply in the image, and m is the magnitude. And also we use 2 loss functions. The first one is cross entropy. The cross entropy is the most common loss function that we can find in the literature for classification problems. And also we use focal loss. The difference between cross entropy and focal loss is a factor. It's a factor that we have here, and this factor decreases the sample that the model classified well and focus on misclassified examples. So for the model training, we have 20 models in total, because we combine all the models, all the data argumentation, and all those features. So finally, we have 20 models in total. For the training, we use 25 epochs for each models. We use a batch size of 16. Also, we use a lightning environment for multi-GPU because we have a lot of data, so that is the reason that we have to use more than 1 GPU. And also, we use an optimizer that's called AMTC, and we use a scale that it's reduce en plateau. So this is the result that we have for the SUSCAN net. So here in bold, so we can see in bold here, but here we have the best result. And the best result is using V-transformer. That is very important. And also we applied a GradCam analysis. And for the GradCam analysis, we can, at first sight, we can say that for the date model, we had the best GradCam. More than the other one, more than the other visual transformer that we use. I think that is better. That we use, and it's important to highlight that for unbalanced dataset, it's important for evaluate them, it's important to use the FM1 scores. And here we can find that for the date model, we can find that for the swing model, we had the best result. Okay, for the Hura result here, we use the best combination of that augmentation and loss function for that based in the SUSCAN net result. So here we can find the same results that we had before. That means that for visual transformer we have the best results. And also we applied a GradCam method, and at first sight we can conclude the same as before, that for the date model we have the best results. So for explainability analysis, so first of all, I'm gonna explain a little bit what is GradCam. GradCam is a method that very, very common in deep learning approach, and is used for understanding how a model has been driven to make a classification decision. So in this case, we use 6 GradCam methods, okay? 6 GradCam methods, and the difference between these GradCam methods is the way to compute the activation point. For example, for GradCam and X GradCam, this one use the gradient to compute the activation points. And for example, SCORCAM use the activation feature maps, and AgentCam use the agent vectors for feature maps. So also, I'm going to explain a little bit what is ROAD. ROAD is a vector that we use to evaluate different explanation models. So this is the formula for that. And for the first term in this formula is the classification confidence score after perturbing the least relevant pixel, and the other one is for the most relevant pixel. Okay, so let's go. So for the GradCam analysis experimentation, we compute the road metrics across all classes and conduct a permutation test. And for the Bayesian test, we do 2 experiments. The first one is using random cam. What is random cam? Is random feature maps. So any GradCam methods should be better than random cam. So that is the reason that we use for the first experiment random cams as a baseline. And the second experiment for the conclusion that we had before, because we can conclude before that for the date model we had better GradCam images. So for the second experiment we make the hypothesis for that. So this is the result for the first experiment. So here for using the swing model and the SUSCANNet dataset, we can conclude that for AHACAM has is significantly higher than random cam. And for HUI, we have 3 GradCam methods that are significantly higher than random cam, and other ones that are not. And for the dates model, we using SUSCANNet, we can see here that the ScoreCam underperform all the GradCam methods here. And for HUI, in this case using date, we can see for the GradCam++, outperform random cam, and for layer cam is the opposite. So for the second experiment here, we can conclude that for the SUSCANNet dataset, okay, we have some GradCam methods that are significantly higher using the date model. Using the date model. So that's and for the other case, for example, when we use the HUI dataset for all the GradCam method, we can conclude that for using the dates model, we had better GradCam images. So in conclusion, we are the first to address this problem, of Plankton image recognition using the entire dataset of HUI and SUSCANNet. And also, we can conclude that we have the best result using V transformers. Okay? And for the GradCam method, we can conclude 2 things. The first one is that we have some GradCam method that underperform and outperform the random cam, so we have focused on that. And the second conclusion is when, for the SUSCANNet, there are some GradCam methods that are significantly higher using the road metrics, but for the F1 score, the swing model was the best. Okay. So what's next or now? What I put now, because I'm working at it, so that is the reason I put now, but it's the next steps. So for the next steps, we want to apply more data augmentation, but data augmentation for long tail data, in this case, like CUDA, CMO, DODA, and also we want to apply more sample methods, and more loss function like LDAM, asymmetric loss, more models like EfficientNet, EVA02 also. And also we want to do an open source code, and for the all models that we train, we want to put in an easy to use format to facilitate the adoption. So thank you very much for listening. That was my presentation.
Thank you. You know, normally I complain that Sofía presents too fast, but today was a feature. So
I do my best.
Do we have time for
my
one
best.
question? One question.
No, it's okay. I did my best to do that fast.
No question?
No.
Not even one question. Yeah? Do you have one?
I want to speak in Spanish. Is okay? Do it fast? No?
No, it's in English.
Ah, well.
I prefer.
La pregunta, ok. Yo sé que hay un beneficio de trabajar en Inria Chile y por eso estoy más al tanto de lo que tú estás haciendo. Pero te quería hacer una pregunta de todo el proceso. ¿Cuál ha sido la fase más difícil de identificación de los recursos que te sirven para tu investigación?
¿Qué ha sido lo más difícil para la investigación?
¿Cómo es la pregunta? Like the question is, what part of this processing pipeline has been the hardest for you to handle? I have the answer. It's bearing with me.
Yeah. Yeah.
But no, go ahead.
I think the training, because for long tail problems, we have a lot of data, and we need a lot of GPU, and this processing could be very, very long. So I think that is the most difficult part because we have to wait a lot. Yes. That is the answer.
Thanks.
Mm-hmm.
Well, we don't have time for more.
Yeah,
Thank you,
I know.
Sofía.
Yeah, I did my best to do that.
So, we want to continue with the round table. Let me see, yes, round table, challenge and impact of AI. And the moderator is Nayat Sanchez. Welcome to the stage. And I want to invite a Sebastián Amaral, de IDEMAX, Isidora Cabezón, the Center for the Technological Revolution and Creative Industry, Rodrigo Durán, the National Center for Artificial Intelligence, and Fabián Leboré from Inria. Un aplauso, por favor.
Okay, thank you so much. I think you two need to share mic. Julian and no, but it's okay. You can share mic. Okay. So.
There's one. We can share more than one then.
So thank you so much. Thank you so much for being here. Thank you so much again you to stay till right now just to hear us in this panel of the challenges and impact of AI. I have the pleasure to share the stage with some colleagues from Chile and also from friends from Inria. And I want to start by introducing Fabián Leboré. Fabián Leboré is a political scientist, graduate of Sciences Po Strasbourg, with a master's degree in European politics and public affairs and a diploma in machine learning and artificial intelligence from Sorbonne University. Director of India's artificial intelligence program for the last few months. He was deputy director of this program before that. Previously, he worked at the French Ministry of Economy, Finance and Industrial and Digital Sovereignty for more than 7 years, and where he specialized in public policies related to AI, being in 2022 to 2023, deputy coordinator of the French National Artificial Intelligence Strategy. Okay. Well, there, no, I will finish. There he sets funding mechanism for research and innovation projects, work on plans for training in AI, regulatory issues, testing, experimentation, certification, and he was also part of the international representation as part of the Global Partnership for Artificial Intelligence of the French presidency in 2022. Thank you so much, Fabián. And he was part of the keynote this morning. So I have also the pleasure to share the stage with Rodrigo Durán. Rodrigo is a commercial engineer, Master in Science in Economic and Public Policy from Adolfo Ibáñez University, Executive Director of the Latin American AI Index and manager of CENIA. CENIA is the Center of Chilean's National Center for AI. I did it well, okay. Since 2023, where he's responsible for the areas of technological transfer and institutional linkage. He was president of the talent table of the Senate of the Republic for the draft AI Framework Law and co-president of the AI Working Group of the CELAC Digital Alliance for Latin America and Caribbean. Before that, he was head of the staff of the Undersecretary of Science, Technology, Knowledge and Innovation of Chile until 2022, contributing to the installation of the recently created new Chilean Ministry of Science. Thank you so much for being here. We also have a Julián Hernán. Thank you for being here, and thank you. I know you have a tight agenda. Julián Hernán was instrumental in founding and now leads the Boston Consulting Group's tech and AI practice in Iberia, Brazil, and Spanish-speaking South America. Julián is an active member of the Latin American entrepreneurial ecosystem, serving as a startup, venture accelerator, advisor, an endeavor mentor, and an angel investor. He's currently teaching in the MBA and Master of Innovation programs in the Catholic University, and is currently part of the Innovation Cycle at ICARE. Thank you so much for being here. Sebastián, just here, is a partner in IDEMAS Business Consulting, a regional business transformation consult with offices in Mexico and Chile, but it's a Chilean company, right? Okay, based in Mexico and also Chile, which generates value from strategy and scientific knowledge to promote and give life to a future with companies, businesses, and organizations relevant to the world. More recently, focused on helping companies the adoption of responsible AI. Okay. He's professor of the Master of Innovation and Design at the Adolfo Ibáñez University, and is dedicated to the strategy, facilitation, and management of projects for sectors such as mining, energy, and food, to mention a few. Thank you so much. Thank you so much. And finally, but not last but not least, Isidora Cabezón. She's a Chilean journalist, cultural manager, and actress. She has an amazing career, has been linked to creation, cultural management, and communications in public and private positions. She has worked in television, as a scriptwriter and audiovisual producer. She was editor of the magazine specialized in visual arts, Artes Sin Límites, founder and director of the Eastern Island Film Festival Rapa Nui Film Fest, head of the regional coordination of the National Council for Culture and the Arts of Chile, currently Minister of Culture, Arts and Heritage, and coordinator of the artistic programming of Corp Artes Foundation. She was coordinator of creative economy at Corfo, the Chilean economy agency, between 2018 and 2022. And since February 2023, she's executive general director of the Center for the Technological Revolution in Creative Industries. Thank you so much, this fantastic panel that will be here with us, sharing some opinions, okay, and discussions about the challenges and the impacts of AI. I mean, building probably on the insight of the previous sessions we have been discussing yesterday and also today morning about the infrastructure, the frugal initiatives, the democratization of access, ethical issues. And I want us to especially focus this afternoon on other societal impacts, other challenges related to the evaluation of AI, also the regulation frameworks and the safeguards of the rules of law adoption, innovation, intellectual property, environmental impact of the AI. I know this is too much, but I hope we can say a few words, at least from your perspectives. This is a very diverse panel. And again, thank you so much. So I want to start. I want to make like divide it on three parts. I want to start with the regulatory framework and innovation, just because we have, and I want to show a little bit, I mean, the European side of this thing. I mean, taking advantage of the expertise of Fabian also, and also from the Chilean side with the more recently AI law that is in the Congress, right? So, Fabian, I want to start with you. Then, due to your expertise, could you elaborate a little bit more on the specific challenges and opportunities also, because I know that we have opportunities but also challenges with respect to AI Act. And how do you think in the way it is written, it balances in a good way innovation and risk mitigation? So what's your opinion on that?
Thank you. So to summarize about the AI Act, it has been adopted this year, and there is a progressive entry into force that will be final in August 2027. So it's an extraterritorial law, which means that, for example, Chilean companies that are putting product on the European market would have to comply with it. And it's also an auto-certification process where the company complies with a set of obligations, puts the system on the market, and then there is ex post control. So it's obviously a challenge today because when you look at the obligations of the AI Act, the system must be resilient to cyber attacks. It must be there must be an analysis of the risks, the continuous risk, and included the risk of the system being used in another domain by a malicious user. So there's a lot of obligations that are today set in terms of words and obligations, which can seem sometimes relatively vague. And there is a whole work ahead in terms of evaluation. And when you think about evaluation on all of these type of criteria, a lot of them are still at a research phase. So it's a challenge for companies, for administrations, but also for research. So, and the discussion today, that there is a new science that is emerging, that is the science of evaluation. We talk about it a lot since a few years, and especially with the advanced systems, such as LLMs. And there are a lot of research questions that are open with regards to the science of evaluation. For example, if you need to assess the risk of a system, you also need to assess its capabilities. And the more advanced the system is, the more the capabilities are. Now, when you assess the risk, you also need to set a threshold for defining above which threshold the system is safe or unsafe. With the thresholds comes also the question of the acceptability of the risk, and it's also some kind of a social debate and philosophy question. So there are lots of challenges for science, but also for the society as a whole. So it's not a finished science. It's not. There are a lot of things that are still open. Also, when we talk about bias and the bias induced by society, I mean, there are lots of things which are not finalized and which will need a lot of work. So at the international level, there is already a dynamic with some institutes that are. So in France, we don't have it yet, and it will be probably a bit delayed by the political situation, but there is already this network of Institute for the Safety of AI that gathered for the first time in San Francisco 2 weeks ago. And so there is already this common international approach, and at national level we also made proposals for the government to fund a research program that I presented this morning, which focuses on cybersecurity, extreme and systemic risks of advanced systems, and quality of the system. So there are a lot of domains that needs to be funded in all of the countries because it's also a very diverse science and interdisciplinary. So work is ongoing, and so to come back to the question of the regulation, yes, it's quite a challenge, and we hope that the regulation is needed, because obviously there are cases where there are some real dangers in the use of the systems, but it's today is still a challenge to see how effectively it will be into force.
Into force. Absolutely, Rodrigo. I want you to build on top of what just Fabian said about European, legislation and so on. And could you discuss a little bit the unique regulation landscape at least in Chile? We have a new law of AI that is discussed right now. It's being discussed right now. And how this changed a little bit the landscape in Latin America also? And how do you think, how are countries in the region also addressing the challenge of AI governance? So can you probably address both?
Yes. Thank you, Najat, for the invitation and to share the panel with people that I kind of admire. I didn't know you until yesterday, but you seem like a very interesting person. So, well, when you see Latin America in the perspective of the global orchestra of AI, you see a very, very delayed region. Like, we are not participating at all, not in some highlights, like, for example, what Sofía shown before. There are some interesting stuff, but less than 0.5% of the patents on AI comes from Latin America, less of 0.05% of papers on conferences comes from Latin American Caribbean. So we are not participating at all in an important way in the discussion or the development of this technology. And in that perspective, Chile is making quite well, but like in that perspective, because of a very strong ecosystem of universities and also research centers like Inria or Senia or CETIC or whatever. So considering that, I think, and we have been proposing from Senia in the multilateral spaces that we are participating, and that's not only from Senia, but we are endorsing that position, that there's a need of a Latin American view on how we're gonna to endorse or promote AI. And probably taking this regulation view that it's very necessary, but I don't think it's urgent, from the states can be a problem. It can be a break for development. Because Fabian just said, they are having troubles in the UA having the whole regulatory ecosystem that exists in Brussels. So you cannot imagine that if we are applying the same recipe of AI risks framework to our regulation in Chile, because the Chilean regulation, it's looking for regulate, to establish limits. It's not promoting, it's not developing human capital, no, it's only regulating and sandboxes, that's all. I think it's necessary, I don't think it's urgent. And I don't think it's urgent because of the context that I mentioned you before. So in that way, you can also compare the Chilean law that probably will be the first approved in the region, or maybe Brazil, I don't know, but Brazil is like another continent itself. So if you go from the Amazonia to the Pacific and Argentina and Chile, probably Chilean is going to be the first. And as we have a leading score in all the measurements, when you compare with Latin American countries, they will say, okay, we should follow Chile. So we have a responsibility, regionally speaking, to make a good law. And I think we are not making a good law in this moment because of two reasons. The first one I have mentioned, but two specific ones. Principally because of the PI restrictions that are suggested by some parliamentaries. They are trying to create a new intellectual property standard on data for training models that don't exist anywhere in the world, and that will be catastrophic for the use and the development of models. And the second one has to do with the very deep specifications that they are proposing on principles. Principles must apply like generally, and they are trying to force them to apply in some specific areas. And I go back to what I think it's a good idea, to establish a law that can be taken not only by Chile, but as an inspiration to other countries in a way that you can build like a regional market. And that's what I wanted to finish with. Chile has not the size to be an attractive place to invest in AI unless you can export that solutions to another markets in the region, because we are too small. So if you have a regulation that fits with what's going to be the other regulations, probably it gets much more interesting than if you have a regulation that restricts you a lot and that has nothing to do with what's happening in Peru or Bolivia or Uruguay. So I think, well, that's something that worries me.
Yeah, well, we need to balance. We need to balance. At least we have an initiative, right? At least we have an initiative. Yeah, absolutely. And I would raise a question for you too. Okay, yeah, for you, Julian, and also for Sebastián, right? How can you think from the private sector, how you see things with respect to regulation, with respect to how are they flexible enough for a rapid technological adoption, and how you think these things from the private sector perspective?
So first of all, thanks so much. It's really a pleasure to be here, and especially with this great audience and moderated by Unayat. Thanks so much. And also, is the previous presenter still in the stage? No, I think so. Congratulations. I remember when I used to do that at MIT, and honestly, you handled it much better than me. So a round of applause to her. She was super good. Again, I'm gonna, I don't want to Rodrigo said it super well here. And again, we really need to understand where we are today from the regulatory part, but also understand the mindset of the private sector, because honestly, this will never happen if we don't use the best of what we can bring from the regulatory side, from the scientific side, and also from the companies. And I'm gonna start with a figure, 22%. 22%.
What?
22% is the number of companies that are moving ahead beyond proofs of concepts in AI. 22%. And do you know how many of the full base of these companies are really seeing a significant impact in their bottom line? 4%. 4%. It's crazy. And again, we are we're in the ecosystem here. We're coming to this, but sometimes we get too close to the trees and we miss the side of the forest. This is a massive, massive, massive area of opportunity. We're still in the beginning. We're still, despite the fact that this was from 1956, and again, I'm one of the guys that started coding in expert systems. We can talk about that later. But again, we're in the beginning, and here everything is up to build. And the perspective from at least what I've seen working with my clients in the region and also abroad, and we're seeing this in France also, and again, this is the same discussion, so that's what it's so interesting, is that companies that really have a vision, companies that really understand what they want to do, and they see AI as something that's going to transform their business processes, those are the ones that are in the 4%. Companies that see this, okay, I'm going to go and I'm going to try, I'm going to go and I'm going to learn, these are more like the 22% that makes it. And the ones that are still on the fence and trying to do this, actually today we're seeing that these people that try and do these proofs of concepts are not really doing themselves a favor. Why? Because they're not committed. And in order to really make a change in AI, you need to be committed. So if I can leave you for something on the perspective and we can really delve deep into this, my thoughts would be, from our perspective, from the people that are in the business, let's try to see the problem from the other side also. Let's try to help the companies understand that this should be part of their strategies, and they really need to go bold into making this a rethink of their business model, more than necessarily a technology.
Absolutely. What are your thoughts?
Thanks for... I see. Okay. Thanks for the invitation, Inria and Nayat. From my perspective, the boundaries of the law or the regulation are things that companies in Chile don't need to resolve right now, because we have other problems in terms of amount of investment, in amount of courage to do some things. And the boundaries will be set in terms of legislation, values, and that's going to be the field where we have to play. But in the game, we need to set a point of view to define where do we want to go, and maybe we need to start making questions that technology or AI it's going to answer. But if we don't have the questions, we will have wrong answers. So in our business, which is strategy, innovation, and relates scientifics with companies to develop new solutions for biotech or data, we are trying to make those points of view and that perspective, so we create like an innovation option to create value, to understand in a better way the future scenarios, and to get ready for that. And we are not scientists, so we need to get related with the ecosystem. That's why we signed an agreement with Senia or Inria, because we are not going to solve this thing only with our capacities. So that's the thing that we are doing with our customers. Ask questions in order to get answers related with technology, because we know that's going to be the scenario. And after that, we will take care about the boundaries of the legal ethics and all those things. And we are provoking our clients. Maybe 5 years ago, we invited to Chile to Tristan Harris, before he was famous of the movie of social media dilemma. And there's some questions that companies are not even asking. And that's the thing we are doing, and that's our first point of view that's going to define these boundaries or these ethical problems, and will compliance they have the obligation to make things happen in these boundaries. So we are maybe in early stages than regulation.
No, it's okay. So this is not working, okay? Yeah, absolutely. This is related with again, with innovation, with the adoption, I mean, the private sector, but not only. And this is, I mean, what you're doing, I mean, in this between the scientific world and the industry at the end, it's very valuable. I want to jump into another part of this discussion, which is related to AI, to culture, and to the future of work. What about everything is related? I mean, I'm passionate about the connection of AI and at the end, with the arts and with the culture. And in this respect, Isidora, can you tell a little bit, just a little bit, about what the Center of Technological Revolution for Creative Industries is doing right now in relation to AI, and what are the main concerns with respect to the artists where you're dealing with? I may guess some of them, but I want you to approach them. So.
Thank you. Well, also thank you for the invitation. Just, I would like to add a little comment of the question before we were discussing, that it's not only having a discussion in between countries, it's also having a discussion in between sectors. And that is why I'm very happy to be here, like representing the creative sector, because we have different challenges. There's a good example. The World Economic Forum at Davos in January invited musicians, artists, and creative to be part of the discussion. And that is one of the main issues about regulation on AI or developing AI, to make these explorations together. So that was one of the points I would like to add in the discussion. And what we do at Critic, this is a technological center for creative industries. We are a non-profit foundation with the support of Corfo and 7 partners. One of the partners is Inria, so we're happy to be in the same panel and invited by Inria, because what we are looking forward with this technological center for creative industries is to add value to a global strategy of the Chilean innovation chain, isn't it? So we want the creative industries with the technological tools to work with all the rest of the sectors in order to make an innovation hub from Chile to South America. And we share lots of challenges, for example, with the Latin American point of view when we had some discussions, because we have a different perspective as Latin Americans, as Chileans. And related specifically to the challenges we have to manage in the creative sector with AI, maybe I would like to point 4 main challenges I see. Well, first of all, intellectual property, of course. In this area, we see like 2 different challenges. One is what I always describe as AI, intellectual property forward. What and how we regulate like the new pieces of art created, co-created with AI, one. And the other one is intellectual property backwards. So how we regulate this data that we input to the algorithms that create a new piece of art. So there's 2 different areas, intellectual property. The other one is the cultural biases. If we add only, for example, information in English, we will have a vision of the world in an English perspective. Because language is not only about translating a word, it's also about the way you conceive the world. So it's very, very important for the creative, from the creative and cultural perspective, to add this information, to train these algorithms with different and diverse cultural point of view. And for example, language is one of the most basic ways to make or to prevent these cultural biases that you can have in the training of algorithms. The third point, it would be, of course, like digital skills. We as creative sector, we have to be more competitive in these new skills. And the fourth one, I would say, is like an aesthetic dilemma. And because of the democratization of the access that you can have with working with an intelligence, with an AI, anyone can create a new piece of art. So you can create music with AI, you can create an image with AI, you can create a film with AI. So what would be the difference? And that is one of the main and interesting aesthetic challenges, because nowadays everyone can make a movie, but go and make a good movie. Anyone can make an image or a paint, you know, like a digital work of art. But go and make your own aesthetic difference. And that is very interesting because maybe, and that is what we want, is to make differences between like the originalities that human beings can add to working with machines. So that I would say like the
Absolutely, I mean it's lovely. I mean the discussion is very provocative at the end, because I mean with respect to art, I mean what is the definition of art for you and for me? It's different. So what is the connection that we have with the art? Is the narrative probably what with human search behind the art? Is the narrative of the artist is something more than I mean a cold picture or a cold movie that you don't connect with, right? So, and this is, I mean, there are so many points, but of course there are challenges and impacts associated to that. Thank you so much for that. What about Julián? We just jump into you a little bit. What about from BCG, but also from your hat from ICARE? What do you see? I mean, also from other companies that in this table seated, we have a lot of discussions in the innovation cycle and a lot of concerns about AI, the adoption of AI and so on, the future of work, the talent that Isidora just mentioned, how we create value, how we connect this with the productivity of the country. So what do you think from this perspective?
Yeah, that's great. The $10 million question. So we have an algorithm at BCG. It's the 70-20-10. 70-20-10. We think that the value here, or where you're going to derive the value from AI, it's 10% on the algorithms. For the mathematicals in the audience, please don't kill me. 10% is on the algorithm. 20% is on the tech. 70% is on the people. People. It's on the people. I mean, the value, it's when you change your processes, when you really, really rethink the things that you're doing, that's...
Close to the mic.
Huh?
Closer to the mic.
Closer to the mic? I'm sorry. Sorry, I was just trying to keep you on your feet. So it's, just to repeat, 70-20-10, 70% on the people. But how do we train our people? What are we going to teach our kids? I think that those are the key discussions that we're seeing our clients right now struggling with. There's a few ones that are thinking of cyber, like what Fabian was mentioning. There's a lot of discussions on bias. There's a lot of discussion on regulation. There's a lot of discussions on the innovation. But if I had to leave you with one thing that the companies are worried is my people. How do I train them? How do I really turn them into, for the lack of a better word, of cyborgs that use the technology and then enhance their capability more than thinking that the technology is going to replace them? So there's I'm a huge nerd and I love science fiction. And there's a phrase that gets, it's born from the book Dune. Right? Has anybody read Dune by Frank Herbert? No? Dune? Duna? Duna? So, my favorite book too. I love it. Science fiction. I'm a huge nerd again. And in the book, there's one part that the narrator speaks and he said, people were worried that they were going to get ruled by machines. In the end, they got ruled by people with machines. And I think that, I like putting it in another word. I think that in the end, the future is from the people that really see that working with the machines, we're going to be more productive and we're going to be happier and we're going to be able to devote our time into our more creative side. And I'm happy to see here, Isidora, that you guys are pushing that. Because that's where I think that we should use the technology and liberate the potential of the people.
Yeah, thank you, Sebastián. What do you think about that? About the talent, about the challenges that we have?
I was thinking in an example for a mining company. There was the scorecard for the executives was to implement some technologies. And we were working on a security and safety program. It was called Safety Challenge. And we made an innovation program for that. And from the corporate offices here in Santiago, in a very fancy building, they bought like 100 iPads to improve data for security. But they didn't know that in the mining, in el rajo, in the place where the minerals are, there was no Wi-Fi. No Wi-Fi. The workers used security items like glasses, like things to breathe, guantes, how do you say guantes? Gloves. So the executives won their bonus because they check the scorecard of digital transformation, but we didn't get any data. So how companies are going to develop technologies knowing the real problem that they are having, and how are the incentives for the executives be aligned on the future scenario. And today, this is not happening, or not happening in the percentages that we should take the advantage of the opportunity. So this is a great challenge. How are the executives or the companies are going to put more money to invest in technology, but in technology that's not as it's not guaranteed. So maybe that's the main challenge. And we need to do maybe 3 things. The first one is like sense of urgency. This is a problem now. We have to take care now. We have to do it seriously. Seriously means with headcount and budget. And this is a vertical thing. This is mandatory. This is not an employee's decision. This is a strategic decision to do it. And if the shareholders are not convinced of that, this is not going to happen. And that's what we're working for, to convince the shareholders to put the strategy and the place to go in the boundaries of the legislation and compliance to move it. And that's what we're doing, and maybe that's the main challenge for us and the companies we're working on, with the example of the mining company.
And the incentives are key, of course, to do that. I mean, everything and everyone has a role here. I mean, the public sector, the private sector, and the academy, and and everyone. I want to jump into another point, which is the future of work, which is connected to the development of talent. And this morning there was presented a program that we have in France, right, associated with the Ministry of Work. And I want you to say a word, Fabian. And after that, I want that you, Rodrigo, also jump into the topic. Just to mention, what about Chile, in this respect, and what do you see the region with respect of this topic?
So exactly, when talking about the impact of AI on work, the Laboria that we launched at Inria with the Ministry of Work is a place where we launch some research action. We call it in French, recherche action. So it's kind of a neologism because we get often asked, for example, in this type of events, so can you determine in this year the amount of people in this sector that will be affected? That's a very quantitative approach, and that's not the approach that Laboria is following. The Laboria is really looking at the qualitative impact. We are really looking in the field, within companies and administration, and measuring this impact. So the first phase of the Laboria has highlighted interesting things. The first one is that when we talk about people working in a company where an AI system was deployed, they do not have the same vision about AI. They accept it with optimism, rationalism, whereas when you look at people that have not experienced the deployment of an AI systems, they often have fear related to its impact. The second thing that we highlighted is what Juana presented this morning about the conflict of rationality. So when deploying an AI system, the first motivations are based on economic reasons, such as cost, efficiency, safety, helping the decision, and etc. And this rationale enters in conflict with other dynamics from the worker that are his know-how, the perception of his competencies, the way he acts with the collective. Obviously, these two dynamics do not go well hand in hand, and there is, and for example, when we talk about creative industries, and the fact that you mentioned that is a creation by an AI art or not, that also impacts in a sociological way the worker on his way of seeing his autonomy, his know-how, and his added value. So there is a real need on the field to accompany the deployment of an AI system, which has not been done so far pretty much in the past. Since the first step, which is why do we need an AI, we need to include and incorporate people that will work with it before even setting the objectives of the system in order to determine their needs, the environment. What is very important also is to look at, we say, real work and not prescribed, or real job and not prescribed. I mean, when you look at your job description, it will detail what you do, but it's not the real work that you are doing on the field with interacting with people and interacting with the machine. So this is very important to really look at that with acuity. So the work of the Laboria is to observe these scientific and sociological impact of AI, but also to propose methodologies, chronological methodologies, in order to accompany within a company, within an administration, the deployment of an AI system, step by step, before, during, and all along the life cycle of the system.
I see there is strong space for collaboration with Chile. What do you think, Rodrigo?
Yes, there's a strong space for collaboration at all. Like, because when you look to Chile or Latin American countries and you try to understand the future of work, the first thing that you hit is the lack of data, public data. So you have to work with private data. The biggest source of private data, it's LinkedIn. So all what I'm gonna say, it's based on LinkedIn data, crossed in Chile, Argentina, Uruguay, and Colombia with public data where you have enough data sets, but the rest of the country, you don't have enough data to understand the phenomena of how it's going in the future. So when we think about the phenomena considering Gen AI, it's very different of the other phenomena that were allowed by other AI tools, like, for example, using a robot based on computer vision to pick apples in a production chain was some kind of automatization when you took a low-skilled worker and you put a robot that was more productive. And that robot makes all the job. So the job was taking apples. But with Gen AI, the variety of occupations and tasks that can be held by the technology, it's huge. It's much more bigger than computer vision or robotics. It's another way of thinking. And that means that, and that's the research that we have made, in all the 100 more important occupations in Chile, there's no occupation when you can replace people, because there are critical tasks that LLMs cannot accelerate, they cannot replace, and they cannot make at all, because they have to do with making decisions. And robots, you can program them to make decisions in some certainty world, but when they face uncertainty or something that it's not on the prompt, they are going to be to hallucinate or not do anything at all. So considering that phenomena, I think it's very complicated to project the future of work in a concrete way, but I'm sure that the impacts will go in a way very similar of what we have seen in Europe in the 1980s, in the 1800s. So the impact was not only on the way that we produced, it was also in the way that we lived, like the migration from field to the cities, the construction of a new social class, the rise of the bourgeoisie, the revolutions. That all happens because the enabling of massive production. And we are facing a new way of massive production that we haven't faced in the last 100 years, I think. And I think if you want to embrace the opportunities of that, the biggest challenge is first to have data and then to understand the trends. And there are two trends that we are putting some attention. The first one has to do with engineering skills. And when you see engineering skills in Latin America and Caribbean, we haven't matched in the last 8 years where the northern countries were 12 years ago. So we are very, very below the capability to even match what they were doing 10 years ago. And that's very scary because there's no way that we can build sovereignty, or sovereignty, I mean understanding of the technology, if we are only adopters. Sometimes we can develop, but it's not something structural. But on the other hand, with the surge of these Gen AI skills, like literacy on AI, there's another story because all the countries are very, very back behind. Like Uruguay has the same relative penetration of AI skills based on literacy than Israel. That is the leader in all the other. So if we in Latin America take serious the idea that, okay, this is going to change the way we produce, we live, we vote, we do everything, maybe we need, as you said, like to improve that kind of skills. Not having engineers, that's important, but much more important from my point of view today is to have people who understand and can interact with these tools, because they are going to be everywhere in the future.
Thank you. Isidora, do you have a final thought on that?
Yes, I was thinking about the idea that you said before, that in the Industrial Revolution, people moved from the fields to the cities. And now what is happening is all the way back, isn't it? So nowadays, people from the city, they're going back to the mountains, to the fields, etc. And that is a new way of living and working and making a society and making a cultural revolution also. And the other thing I was thinking about, and related to the comment you said also, is that now with this new Gen AI, indeed, I agree with you that that's the real revolution. What about the creative initiative all the human beings have? Isn't it not only about the creative sector? I am talking about like the capability of creating new worlds, new ideas, new languages. And what we expect and what we would like to happen and what we are pushing is that in the future, but now, because the future is now, is that, for example, companies can add in their teams, in their crews, like new visions. So creative, I'm talking about professionals, the creative sector can also start to work with other disciplinary sectors, other industrial sectors, because what we need is what we as human beings have. And maybe the professionals in the creative sector, we have like that curious things of making questions. You said the point is not the answer, but the question, isn't it? So we can also start to work more in an interdisciplinary way, so we can add value not only to an artistic process, but also to more high impact process in other sectors. So I think that those ideas are important to consider in order to work more together.
It's a very, very, very fantastic discussion. I mean, it's a pity that we don't have so much time to continue, but I want a final tweet because I want to drive you to one particular topic with this, the AI and the relationship with climate change and environment, and this is something that Sofía just talked about, I mean, in the previous talk. I mean, it is clearly a way, and Sofía just presented, I mean, this two-way around that we have with AI and climate change, right? So in the first place, it's very well known that we can use AI to address climate change in terms of applications, right? It's very well known, we can know so many, right? Another way is using AI for, I mean, in the way that that Sofía just addressed to understand the complex problem that climate change in relationship with other, I mean, biodiversity, oceans, and so on. And what is the relationship in so many aspects? And the other thing, the other way around, is taking care of the impact of the AI, right? Because it consumes a lot of more energy. I mean, it's not an infinite thing. So and this has to do with the sustainability also of the things that we do. And it has to do with companies in the way they make the decisions, and also the incentives for companies and CEOs to invest in one thing or another based on principles, for example. But it also has to do, because all of this that we have been talking about is related with the science at the end and the need for more science. So what are your final thoughts? One tweet and we finish. Thank you.
So just a few remarks. Yes, that's obviously a crucial question. Today, research teams are focusing on many different aspects related to frugality, such as new architectures in terms of hardware, theorems of learning that are more frugal, but also developing models that can function with less data and are as perform as well as big models. The funny thing is that one remark is it's also quite ironic to see that some companies that are selling and putting in accessibility open source or proprietary models and that are always arguing that bigger is always better are the same companies or pretty much linked with other companies that are also selling their cloud and HPC infrastructure. So there is kind of a ironic link between the two, and when you see that the much smaller models can have a little bit less of performance but be quite performant in the end, you see that there is some kind of a strategy probably also there. And one thing that there is obviously a need to change the paradigm at world level, and I think one important thing would be to incentivize researchers, for example, in big conferences like NeurIPS, to incentivize the frugality as a prerequisite before publishing any paper. That would also be a total change of ideology, paradigm, and that would really help advance science towards frugality.
How is this connected to companies? What are your thoughts? Rodrigo, go ahead.
On the same topic, today was launched the National Plan on Data Center in Chile. And from my point of view, the biggest economic opportunity that our country has on AI is data centers for AI, because they are intensive in consuming energy. We have a very good connectivity with the Northern Global through 3 cables that goes from Puerto Montt to San Francisco, and also this new cable that it's building Google from Valparaiso to Australia. So you can dream with a hub of data centers and data-driven solutions in the north and the south of Chile, if you put the right incentives. And that means, like, for example, making it more easy. I participated in one of on the conversations, and someone from the industry said, there are like 85, like, ¿cómo se dice trámite? Like, trámites. Progress, like public stuff that you have to fill before starting the process of having the authorization to build that data center. So if you compare that for, I don't know, Brazil or other countries, that the permisology, exactly. And that's something that it's, for me, it's quite not, I'm not saying to build them like in Coquimbo or Santiago where you have lack of water, but for example, you can build them on the north with desalination stuff and all this stuff. And the market, it's completely huge. It's infinite. Like, it's only growing. It's growing faster and faster. Like, the big techs are buying nuclear plants that were closed 30 years ago to feed their data centers. So obviously there's a big opportunity, and the question is, okay, are we making enough stuff because they are not going to be data centers based on fossil fuel. They're based on renewable energy. So I think it's a great opportunity.
Yeah, it's a very good point, because there are characteristics that are given, like the natural resources in Chile, but the other ones are the decisions that the government makes to make policies and the right policies to promote all of that, and I think this is a good example. Sebastián and Julian, what do you think from the point of view of the companies? What do you think? Sustainability, how we can put that in the table?
Maybe I was thinking that companies need to think not only in short terms, take more risks, and scientists need to be not only paper-driven in order to make this better match to create value, because that value is going to give sustainability to the companies in these future scenarios.
I'm going to build on that. When I was a kid, you had a 100-watt bulb, and that's all you had. And with that, you would illuminate your house. Today, with those same 100 watts, you can illuminate the house. Not a room, a house. And that change came from scientific ingenuity, governments pushing regulations, and companies looking to do better products. If I can leave you with that, the final message from my side is that if we want to jump in this bandwagon, if we want to jump, we need to do it together. Nobody gets far alone. Not scientists, not companies, not governments.
And not artists.
Yes.
What do you think?
We are the bridge. You know, one of the things we are trying to push the most is the collaboration between researchers, scientists, developers, like technological developers, the government, because what the creative industries have is that we know how to tell stories. So we know how to sometimes translate this information, this research, and to make the people and everyone to understand what we need to understand in order to make changes, in order to convince, in order whatever, no? So I think that we should work in this triangle that is art, science, and the creative industries, and the technologies, like the tool, it's not the objective itself. And if we make that more stronger, I think that we can make more changes in terms of decisions, for example, so we can convince better the decision makers, but also the users. So you were talking about the adopters. to make changes, we have to understand what we need to change, and we need the information to be put in some way to be attractive. And there's also an important thing, and just to end the conversation, is that education is like really, really important. And there, the artists, culture can make the difference. If we teach our kids the most, how to make questions, not only how to use ChatGPT, isn't it, to make the homework, but how they have to ask, how they have to be aware of the information, how they have to use these new tools that will go over and over changing, we can make also a difference for the future. And I think that the creative industries, the cultural sector in general, we can make the difference because we can help in that term.
Absolutely, I agree with all of you. Again, thank you so much for being here, for accepting to be part of the discussion. I hope we can build some deliverables probably for February in Paris. Hope to see you all there. And thank you so much to the audience to stay until here. Thank you so much. Again, just make applause for the... Let you invited for tomorrow's session. We will have a whole day AI for science. This is a very, very nice day tomorrow. So I hope you will be here also attending. Thank you so much.